Fantastic.
Hello, my name is Mikhail. I'm from Moscow Institute of Physics and Technology. Um, I'm interested in machine vision and everything is connected to this field.
Great, thank you.
Hello guys, my name is Oleg Uzhontsov. I was born in St. Petersburg, but now I'm here in Skolkovo, and I'm interested in machine vision for robots and some other portable applications.
Great. You always sit in the front. I recognize you. You have a great look.
Sorry, what?
No, you look great. Like for the poster child of the class, you always sit in the front row. I feel like I know you.
Yeah, we like people who sit in the front.
Okay, thanks.
We're giving you a compliment.
He said thank you. I think I will introduce myself. So I'm from Moscow State University from physics department, and here in Skoltech I would like to learn more about computer vision as well, and so that's probably the reason I took computational camera. I wanted to know more about the vision itself. I mean the devices that could register some objects and how lenses how lenses works and etc. So it's kind of useful for me. Yeah. Thanks.
Thank you. Nice shirt. Next guy.
Hello guys, my name is Roman Prelevsky. I'm electrical engineer already from Bauman Moscow State Technical University. So it's my first specialist degree, and I attend to Skoltech to study more about machine learning and computer vision, maybe as a complex. So that's all about me.
Great. Do you know if there's Skoltech shirts that we could wear? I see you have an MIT shirt.
I bought it after MIT Innovation Workshop, which we had in August. So yes, we have Skoltech t-shirts.
Okay. Gotta get one in here.
Yeah, how about we create a collage from the class with cameras and photos and create a new Skoltech t-shirt. And I would like to wear it for Thanksgiving. Anybody else in the room?
Yes, no.
Okay, all right. So we can spend some time, I believe, during the break to see if you have any questions. We still have a couple of minutes left before we officially start here. Are there any thoughts or questions about the homework or programming environment? Anybody? Victor? Can you hear us?
Yeah.
Okay. So do you have any questions about homeworks or the programming environments or how we're communicating through Google Doc?
Where is it? I have a question actually. Can you hear me?
Yes.
Yeah. So I had a question. So we have a couple of Android device here, but we need to share it between a great number of people. So I tried to work in Eclipse in an emulator environment, and it seems to be working really slow. Is it possible to somehow tweak that emulator to work faster, like on the real Android device? So that was a real problem for me.
So I believe you have 5 Android phones that we had sent from here.
Yeah,
and also
yeah.
5 Kinects.
I mean, we need to share these five phones between a number of people. So sometimes you don't have access to that device, and in case for example, you're like at home on Sunday and you want to test it, and somebody already took that phone. And I try to use emulator, but it works really slow. So my question is it possible somehow to make it work faster? I mean, so you don't need Android device itself, but you work on your laptop with emulator.
Yeah, so there are some optimizations you can do with the emulator. The big case is you usually want to stick to broadly adopted API targets. So 2.3 is probably the lowest end you want to hit on the emulator, but there's also some optimizations you can do, and I'll send you instructions and some links for that. That'll help a little bit, but the emulator typically just has a really slow first start time, and then after that it's a little bit faster. It's very laggy still, and you can actually hook up the emulator with with your webcam as well. I don't know if you've tried that, but that all should work. Send you some links that'll help a little bit.
Has anybody tried
thanks.
with the camera here on the webcam? Because that's a quick way to test without having a phone. Initial potential just then.
I actually tried it with the webcam. It works with the official Android camera app, but it doesn't work if you use, like, I guess the CWAC. It has some bugs. So it's hit and miss, I think.
Okay. I'll take a look, and I'll send you guys some links, because I've definitely run into some of these problems before.
And another thing we have used for sharing cameras is sharing phones. So many members here also sharing phones. I hope you guys realize here is that we have a checkout system. And I know some of you have been using it very well. Who have checked out the phone? Fantastic. So many of you are coming to my lab, and we have a checkout system where we have phones sitting outside my office. And you sign out, take the phone, and you can bring it back after a few hours or overnight, but not keep for more than a day. So a lot of people have been using that system. So I encourage a same system at Skoltech.
Yeah, we should implement it, because for now we need to, negotiate it between each other. I mean, we don't have like the checkout system yet.
Okay, good. So.
So this was an experiment. It's early morning here. We're kind of tired. You guys, it's late. It's later there. You guys are really peppy. We want to start the next few classes with having you guys just share some stuff, and we'll email you questions ahead of time. But thank you for introducing yourselves. If you liked hearing what they had to say, clap. Okay. So this was very entertaining for us, kind of like Reality World on TV. So if you guys have questions during the class, feel free to ask. Maybe put the class on mute from your end until you want to ask a question, and then jump in. And then we'll see you at the break and at the end of class. And we have a great class today. And I know, Victor, you have some expertise on what we're talking about, so we may engage you on that too. Ramesh?
Yeah. Victor, I don't see you right now, but can you hear me? Oh, good. Excellent. The benefit of vision. Victor, we should connect during the break. And for the homework assignment, we thought we can do a joint assignment from computer vision. Anyway, we'll discuss it during the break. All the students at Skoltech, if you can log into the Google Doc and type your name in the table that we have, so we know you are engaged, and we're going to use the Google Doc for communication. For any questions and so on.
Ramesh, do you mean the main Google Doc?
Yes, at the discoverl.com/Skoltech.
Okay.
I'm going to hand it over to Dan Raviv, who's one of the experts in thinking about real-time computer vision and machine learning and so on. And he's a scientist in my group at Camera Culture, which means he went through multiple rounds of interviews. But more important than that, for today, he's actually won many awards for teaching as well. So I'm just going to raise the expectations a little bit here.
That's going to be hard for me.
If you have comments or questions, if you use the mic, okay, please start to grab it.
Hi, everyone. Can you hear me? Skoltech? Can you hear me over there? Great. By the way, you do not see that one, but you are like on a big screen on the back of the class. So it's like you are sitting actually here on the last row. Just for the record, you can just pick your hands if you want to ask something. So, yes, and of course you can type questions or whatever you want in docs. I assume it's true for everyone here, right? People here, if you want. Fine. Okay. So. Yes, of course. Yes. So before we start, first of all, if you have any question, really interrupt and raise your hand. Okay. That's the main reason why we sit here. Ask the stupid questions you can think of. Okay. It's really fine. I remember when I did my bachelor's degree, I was the one who always asked stupid questions, okay? And I felt fine with it, okay? That's how I learned, and I promise you that if you do not understand something, at least half of the people here do not understand. Please do not be shy. Now, before we start, I do have a question. In the first lecture in this course, we asked if there are people who need any kind of programming. So I'm going to change the question a little bit. Did someone here ever work with OpenCV? Keep your hands up with OpenCV. Android. So only if you did OpenCV for Android, keep your hands up. Native OpenCV for Android. No, great. Okay, so everybody is going to learn something new basically in this class. Okay, that's a good thing. Now, I have to admit that when first Ramesh told me that I was going to talk about computer vision, and he told me that, okay, let's talk about computer vision, OpenCV, Android, the native, and do that for Android, for glass, and okay, I really think it's impossible, okay? Each and every one of those topics, just talking about programming, just talking about computer vision, just talking about OpenCV, just talking about native programming in OpenCV. Each one of them is a separate course, not a lecture, okay? But there is a Skoltek, I was seeing me because I lost your vision. John, can you please check if they are connected?
It's fine, you can continue.
Okay. So, like I said, so each one of those topics like an entirely different course. But the goal for today, okay, is that you can go home and come out with an app, an OpenCV app on your telephone that actually works, okay? So you know how to put everything together, understand what's going on, and it's like, for you, it's going to be like playing with Lego. Meaning, we're going to show you how to install all the software that is needed, what are the parts that build it, and what are the playing cubes that you can actually use in order to do any OpenCV program. So for example, I'm going to skip to the end and tell you what you are going to do in the end. It's either going to be in this class or the homework, depends on the timing as it goes along. You'll be able to do a face detection algorithm running on your cellular. So you're going to move your cellular around, see images, it's going to find your faces, and the overachievers will actually be able to detect a specific person, for example, as it does that one. Okay? But we'll talk about it in the end. So basically, this is the goal, so bear in mind. So computer vision. Actually, I already shown you this slide, okay? Showing you what is computer vision, so I'm going to skip that one, okay? I remind you that for me, computer vision is everything that has any visual content, okay? So it's not just an image, okay? It can be an image, an IR, in volume, a DTI, MRI data, light fields, and so on. And as we talk about different stages of computer vision in the last 40 years, basically, you are going to see those data basically come to play. Now, in practice, when you're going to use it in this course, it's probably going to be just the web. Correct me if I'm wrong, they're not going to do anything with depth imaging. They're going to do something only regular images, right? So for you, in this course, it's going to be images, okay? So it's going to be either stills or video images. But computer vision goes much more than that. Now, that slide I already shown you, but you're going to do is the other thing here today, currently. We're going to go a little bit from the beginning, which is something like 40 years back, until the topics of computer vision today. But in almost each one of them, I'm going to stop, talk a little bit about it, and we are going to think together, why is it helpful today? And he's going to be amazed about things that people invented 40 years ago, and you see them today, basically, in the most, the state-of-the-art startups that came out using the same tricks. Now, I'm going to be amazed. What is known as digital image processing, basically how computer vision basically started. People took an image and wanted to do something to that image, basically. Now, let's talk, for example, about what is known as kernels, if you want. So, given an image, and I would like to do something with it. Let's assume I would like to blur it. Why do I want to blur it, by the way? I want to get the sharpest image, right? Why would I want to blur an image? In a second, we'll see how to do that. But why do I want to do that? Remove noise, excellent. But if I'm going to blur to remove noise, then what's going to be the problem? It's to be blurred. I don't think you're going to buy a camera, basically, that have everything blurred on it. So there are other methods to remove noise. Now, something around, it started around, I think, the 80s, trying to actually improve the images dramatically, not just by blurring it to remove the noises. But up to, let's say, the last few years, we see beautiful work done in a sparse and redundant representation, which has today state-of-the-art results for removing noise. But that's really way, let's say, in the last few years, okay? But for example, when you would like to do motion compensation. Who heard about motion compensation? What does it mean? Okay, what it actually means is that you have a video, and from one frame to one frame, from one frame to another frame, What I would like to know is what happened, which pixel, where it moved. For example, state-of-the-art compression algorithm, okay, today, do this motion compensation. And when you want to do motion compensation, we actually have some functional, some energy functional that you are trying to minimize, find the best results. And to do that, you want the functions or the images to be continuous. And if you have images with many, many, many edges, then it's a problem, right? Because it's not going to be continuous. And the functions or the minimization is going to be super hard. So basically what you do is blurring. So here's the question. How do you blur? If you actually, that's not a good option. How do we actually blur an image? And that brings us to the concept of filters. Now, the filters you're going to see around the last 40 years. Now I'm talking about the very basic filters that came like 40 years ago. So let's assume for a second that I have an image. Can someone check if Skulltalk can actually see this board?
Yeah, they can.
They can see. OK. So let's assume for a second that I have an image. Here's an image. Actually, I don't think we ever defined an image, right? An image is a matrix, OK? A two-dimensional matrix that at each one of the location in the matrix, you want to represent an intensity. Now, it can be black and white, meaning that it will be just 0, 1. OK, so we have what is known as a bitmap. It can be a grayscale, it meaning that each one of the locations has a number, depends on the number of bits I'm going to actually use. For example, if I have a 256 grayscales, how many bits do I need to represent 256? 8, right? 2 to the power of 8 is 256. Okay, so I just need 8 bits or 1 byte to represent it. So if we're at 256, so each one of the points I have a number going between 0 and 255. Now let's assume I would like to do some blurring for that one. What we actually do, we do a convolution with another matrix. So let's assume for a second I have a matrix which is like 3 by 3. What does it mean, a convolution? It means that you're going to multiply and add each one of the points or the boxes in the original image with the kernel itself. So how can I blur? What would you want to put? Which weights you would like to put, for example, here on the right, in such a way that I get an image which is blurred? Yes? Gaussian. It's a great option, okay? Gaussian is one of the most famous ways to do that. There are, by the way, reasons why Gaussian is such a great option. And to understand why it's a good option, we have to look again something around the 1980s, 1990s, when people talked about pyramids and talked about downsampling and upsampling, and there are many good properties of the Gaussians, okay? But basically what she is saying is we would like to have something that looks like a two-dimensional Gaussian weights in that matrix. By the way, what would happen if I actually put a delta function here? For example, let's assume that I have 1 here and 0 everywhere else. What do I get? Just the identity, basically. And there have been beautiful results, okay, working on different filters, working on the images, super fast. People implement it dramatically, okay, in a way that it's really real-time also on the cellular telephones. And you will see basically next hour that all those functions are already implemented in OpenCV as it is. Just tell us what you want, and it will do it automatically super fast. Now, one of the things that came out of those filters that are highly related to the rest of the results, come from derivatives of the data. Now think, for example, of the following problem. They're familiar with the company called Mobileye. Mobileye is a company that has a camera in the front of the vehicle, actually visualizing the street, the pedestrian, everything that goes along, and allows you basically give you alerts if something basically is going on. There is an app, by the way, that does exactly the same currently. You know how it's called? Eye on Road. Eye on Road. That one works for iPhone. I don't think that they released the Android version, by the way, yet. If you want to just download it, it's for free. You're just going to put your telephone in the front window of the car. There is a very important reason why I'm telling you actually that story. It goes all the way back, by the way, here to the filters. So how does it actually find out where is the road? It needs to know where are the edges of the road. How does it actually does that? Now think, for example, that let's look at the image. And you've got yourself a road. So this is a tree. This is a car, some sort of a car, and this is a child. And you would like the system actually to be able to find, okay, the road itself. What is a road? Share with me. What do you think? What is a road? What are the edges of the road? Straight lines. Okay, straight lines. And the question is, how can we find straight lines very, very, very fast? How many filters do we actually need to do? What are the tricks to do that? So I'm going to show you, for example, two tricks in practice. So the first one relates to that part of blurring and edges. And another one will go somewhere in the middle of the 1990s. I'm going searching for, where was it? Maybe a little bit earlier, what is known as the half transforms. But actually, I'm going to show you how to write this code. Actually, in the end of the day, you'll have all the tools you need to compete with Iron Road. Almost compete with them. So we already know that we want to blur the image a little bit. Now, the question is, how do you find the straight lines? So one of the things that you want to do is take this data of the image that has a lot of information. We said many bits, color images, or even turn it into a black and white image and work on the black and white or grayscale images. And now what we want to do is find those straight lines. So straight lines are actually, if you want, are the edges of the image. Let's think for a second about one-dimensional functions. The topic, by the way, here is gradients. Gradients. And it is going to be basically a super relevant for edge detecting algorithm. So let's think, for example, in one dimension. Okay? So here's the function. It's going to be much easier because from that we're going to just define the filter relevant for that one. So let's assume that we have a function. Straight line going as the x jumps up to some volume, and again it's going to be constant. Okay? So what we have here is a function of f of x. Bear in mind, for example, this is going to be white pedestrian and a white near the pedestrians, and this is going to be the black part of the actual road itself. Okay? And what we'd like to know is we want to find the edges going in between. So how can we get from this function the location or the best intensity possible to actually find an edge? What would we like to do to the function? The gradient function, right? How does the gradient function of this function is going to look like? Well, who knows? Anyone, it's fine. I know it's super trivial for most of you. How does the gradient, so this is going to be f of x, and this is going to be f dot of x. How does it going to look like? 0 everywhere, right? The gradient is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Only one location it's going to get very high value, right? So it's going to get like a delta function, if you want, on the gradient. Now in practice, in real images, we're not going to see exactly a peak in that one. But we are going to see something that looks like a very narrow Gaussian near the edge. Great. Basically it tells us that if you know how to evaluate the gradients, we can find out the edges of a 1D function, for example, quite trivially. Now what happens when you're going to do a discrete version of this one? So now we have a function. Again, we're looking at 1D function. So we're looking at one-dimensional function, okay? And we have a discrete version of that one. So this is our function. This is location x1, location x2, location x3, location blah, 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 xk minus 1, location xk, we have a jump to some location, some volume. Do you see what I'm writing? And x plus 1 going to be the same value and so on. How can we actually write the gradient? So I remind you from calculus 1, the first thing you do in university is actually to define the different gradients. So if I would like to look at the gradient of x at some location of x equals some xk, it's going to be basically equal the volume of x plus minus 1 minus x of k divided, if you want, delta x, which is just the sk plus 1 minus xk. This is the gradient, the discrete version of the gradient. Why am I writing this down? Because what I would like to show you that we can actually write it down as a filter. How will that filter look like? So I'm sure that everyone who did any course in computer vision saw that in the first lecture. So whoever knows the answer, automatically, please don't share with us. Let the rest of the people actually think about it. We have a function. We want to find its gradient. It basically tells us, take the value of the pixel, if you want, in front of me, reduce the value of my pixel, and divide it by the distance. Now let's go back to the images. Sorry. What we want to do first is look at the filter in 1D. So what we have ourselves is a 1D filter, one-dimensional filter. And we have an image. okay? And I would like to find what is the gradient in that row. So we're looking at one diversion, one line of that one. What we would like to convolve with to get that result. Now think what we want. Same convolution as before. We've seen that we can do blurring with Gaussian, as the lady here told us. But now we want to do something more complicated. We'd like to find the gradient of the data. So what would I like to convolve it with? Now remind you, what does the convolution do? Take my volume, multiply it by this weight, add that volume, multiply it by this weight. And remember what I want to do to find the derivation. I want to take the value of the pixel in front of me, reduce it from the value of the pixel, my pixel, and divide everything by the length. For images, we assume, by the way, that the delta x is going to be 1. So there is no denominator, actually. So what do I need to convolve it with? Think about it. Whoever knows the answer, it's okay. You can shout now. Skoltek, you can shout as well if you know the answer. I heard that everybody here did computer vision. You know the answer. I know you know the answer. What do I want to convolve it with? We want that value minus that value. So this value is going to multiply by -1. And the right value is going to multiply by 1. Great. So basically, you've got yourself a kernel that evaluates the derivatives in one direction. That's great. Basically, it means that if you're going to run the kernel, and you're going to run the kernel on OpenCV, that kernel on that image, after it was blurred, because you want it to be continuous, then you're going to get the gradient along one direction. How do you evaluate the gradient, the total gradient? I know how to do that for row gradients. So this is going to give us, if you want, if this is the function f or the image f, running that filter is going to give us what? It's going to give us another matrix, which every location going to have the derivative direction according to the x, to the rows. How are we going to do it? The derivatives according to the columns? Basically the same, right? What I need to do is just convolve it with something like that. And how do I get the total magnitude of the derivatives? Power of 2, sum, power of 2. That's it. And I've got the gradient. Great. That's what people did 40 years ago, okay? Talked about gradients, talked about filters, talked about blurring, and so on, okay? And once we have that, I'm going to talk a little bit about half transform shortly, how we actually find the roads. But this is what people did many, many years ago. So we have block wall, general cylinders, pictorial structures, terracoters. Before structure responded. So people talked about shapes. They've got an image and would like to pinpoint the location of objects in the image. Why is it important? Can you think about an app or a company that does that today? When you take an image and they know something about the geometry and they would like to find how it's located in space. Can you think about a company that does that today? Something that people did 40 years ago, and companies are going out today doing that one. There's a company that, for example, transform 2D to 3D images for sports. They get 2D feedbacks of the sport, transform it to 3D data, and then create a perspective vision as if it was created in 3D. By the way, they are a company in Israel, by the way, that does that. It's a very nice company. But the problem that they have over there, for example, is that they need to find out how the goals, where the goalkeeper stands, okay? How does the net look like? How does the shape of the entire screens, how does the play look like in space? And basically it means that before the game starts, they come to the game, they measure each one of the position of the straight lines in the end. And when you get the image, they are doing the alignment of finding where to put all those known blocks within the images. So people talked about those problems 40 years ago, okay? They're not using the same algorithms, but it's exactly the same concept, exactly the same problem for that. Stereo correspondence. Why do you want stereo? Stereo correspondence means that you would like to get a sense of 3D data. Now, there has been a multiple methods from 40 years ago until today to get depth. First of all, why do we want to get depth? Give me one application to get depth. Why do we like to know just the image and want to know what is the depth of each one of the features over there? Face detection, right? If I can get accurate values of my face, I'm going to get face detection. There are several security companies that are looking at the geometry of the face to actually recognize who you are. You can do that from the 2D, just from the two-dimensional data. But if you have depth, you can do much better than that. You can get signature, which are invariants, for example, for the face transform. Give me another. If you don't know the application, if you don't know the company, just give me the application for that one. Yes?
Scientific analysis.
Okay, scientific analysis, that's great. Today, for example, when you have, let's talk about the Da Vinci system, where it actually does automatic surgery, what they have is a stereoscopic view, okay? So do not generate the 3D structure, but they want to get the sense, okay, of the 3D for the surgeons. If you want a computer, for example, to start doing automatic surgeries, there is a company, not a company, sorry, it's a laboratory in Berkeley, just got several $7 million. Yes, billion is a bad thing.
Did you get there?
Yes, in the end. Basically, they are trying to do exactly what the Da Vinci is doing, but automatically. And they need the depth data exactly for that. But I wanted to talk about a much harder task that can use for many different applications. I think we talked about it in the first hour. Let's assume that I just want to learn or do something with my body as the signature. And you take an image of me. You've got an image of me and the background. And you would like to subtract background. So in OpenCV, when you're going to actually play with the data set, you're going to see that there are functions that performs background subtraction. What I did not actually tell you that it works great for a static background. And if you know it actually a priori, before you actually start gathering the data, it actually works well. But in a general case, it's a super hard problem. But if you have depth, that's simple, right? I have the pixel depth of each one, so you put a threshold behind me, and voila, you've got yourself the data. And think how many companies came out of it, okay, just to be able to separate between the foreground and the background. So 40 years ago, people didn't know about all those tricks, but they did know about what is known as epipolar geometry, meaning that if you take an image from at least two different positions, there are some assumptions, but for at least for two different positions, then you can actually calculate the depth of each point. Can you think about how come it's good enough to know the image, to get the same image from two different positions? Can you think of the algorithm, how it works, for example?
You can calculate the angle
Between?
two images based on distance, and you can.
Okay, you are almost there. I wanted you to stop exactly on the phrase that you just said. You calculate the distances between, you said two images. It's not true. It's not quite accurate. Between a point, which is in the same point in those two images. That's the hard part, actually, of solving all those stereo correspondence problems. Think, I've got an image of the girl who told me about the Gaussian from that point. So I know where I stand. I know where my camera looks at. And I can actually see the tip of your glasses. So in my mind, there is a ray going from me to your tip of the glasses. Now, as I move left, I have another image of you, right? And I see the same point. And I know that this is the same point on the same tip of your glass. And that's another ray going in space. And where those rays intersect, basically, I know the depths. I know where you are in space. But the question, how do I know that this is the same tip? It's the same tip of glass. How do I know that? Yes, but it's a hard problem, right? Because for the tip of the glass, it's going to be great. But what about the, I don't know, the middle of their nose or the sides of their nose? It's a problem, right? Because two pixel sides are going to look almost the same. So what people actually worked a lot about stereo correspondence is trying to find the best algorithms to minimize the error, to find the features to correlate between the different images. People add not just stereo correspondence, or they add multiple images for that one. People added what is known as structured light. Because it's so hard, people projected a light on top of her. And because now light hits her face, some points have the same illumination. And it's much easier to do that. Can you think of a company that does that and was sold for $50 million to Intel? You're familiar with that one? There's a company called Envision. This company basically did that. They did that one and were sold this year for Intel for $50 million. What they are doing over there, using one camera and one projector. The projector projects multiple patterns. So they have 12 patterns. So the first pattern is going to be all white. The second pattern is going to be half white, half black. The third pattern is going to be quarter white, quarter black. You get it, okay? And they change over time. So they have a refresh rate of something like 30 frames per second, 12 times, like 500 hertz. That's basically what they are using. And as I look at her, I get different beams, okay? So every point have a signature in time and space. And from that signature, we know the correspondence. And they will solve, they can get an accuracy of something like sub-millimeter for a distance of like 3 meters, something like that. So basically, Intel is thinking about. Basically, this is the technology they are betting on for the future.
That's the technology that's used in the perceptual SDK.
Yes, for Intel's next.
SDK that's coming up from Intel.
Now think about it. So people did it like 30, 30 years ago. Actually, I came from the lab that actually did that. They actually sold them that product, and it was running on our lab like 10 years before they actually became a product and Intel bought them. But the technology, the concepts goes back 30 years ago. Optical flow, okay? So we talked about a little bit, why do we want filters? Now let's talk a little bit about optical flow.
You want
Now,
to show the 3x3 slide from Zelinsky's book? That has the,
you want that one?
yeah, so you can show the motion and all that stuff.
Okay. So what basically Ramesh is suggesting, so instead of just going over the timeline, let's talk a little bit about the topics. In Slitsky's book, okay, Slitsky, as I said, is one of ex-Microsoft research, basically come and told us that computer vision is huge, too many topics, okay? So this is how he split it, basically, into several different, if you want, subsets. If you're going to open another book, you're going to find different topics appear in different locations. Let me just give you an example. So Ramesh, basically, he's an expert in computational photography. In Slitsky's book, light fields appears, for example, as an image-based rendering. He didn't put it, for example, in computational photography. So you will find, so it's not the Bible, okay? That's what I'm saying, okay? The way that he actually wrote about the different problems. But what is known here as image processing here, for example, it talks about those two filters. When you want to do, for example, more complex structures using those filters, then he shows you, for example, how can you take an image and blend them. Do you remember, by the way, when people did blending? I think it came out from a Michael Jackson clip, I think, for the first time, to do different blending within shapes. How did they do that? They took an image and they made what is known as a pyramid, a Gaussian pyramid or Laplacian pyramid out of that image, and made these changes in a very rough estimation of the image and build it all the way up from there. So image processing talks about exactly that. All the filters, what can we do with that one? Features. So we already know why we need features, right? So the cool words, or the words that everybody uses in computer vision, is sift and surf, I assume, which are basically the basic building blocks of find best features. So give me an image, 2 images, 3 images, 4 images, and trying to find what fits what for those features. In the end, it will probably going to run either sift or surf. The difference, by the way, is that surf you can use as a company. Sift is only for academic use, I think. Otherwise, you need to pay them royalty. And I heard too many people, when they talk about those features, said that when Sift came out, this was a revolutionary concept because it made computer vision works. Because for the first time, you can actually get an image, evaluate something quite rapid on it, and solve very, very, very simple tasks or hard tasks in a simple way. So for example here, what you see here, for example, is the evaluation of a panorama. Can you see why you want to do a panorama today? And I can give you a hint. It relates to what Ramesh talked about in the retinal imaging topics. Why do you want to have panorama images? Besides the fact that it's cool, you can combine multiple images and get one big image. But why do you want to do that today? Yes, exactly. And for example, one of the projects that we are working on here is on retinal imaging, when you actually image part of the retina. The problem is that you cannot see instantaneously the entire retina. You can only see part of that one. Now here's the problem that we are working on, finding the best way to stitch all those images into one big image. And it's something that, let's say, it's on research, okay? So it's not just different tricks that were done in the past. Segmentation. Okay, segmentation, I'm going to go to one slide back and again here, for example. So segmentation, as we told, is to be able to extract the foreground from the background and find what is on in the images. Now, super critical today. Can you think of companies that are doing that today, working on those problems? Medical imaging problems, what do you want to know? Unfortunately, think about tumors. Why it is so important in tumors to know what is a segmentation, how to segment it? No way you cannot think of an option. Why it's important? It's an option, okay? But today, for example, one of the most leading research has done is to see how different aspects of the brain, for example, changes over time. Because usually if they change, it means there is a tumor. And even before you can actually see the tumor, it makes changes into the brain. And we need to segment it. Now, if you're going for segmentation, you're going to find it in multiple locations here along the way. But the one that I would like to stop and talk a little bit is what is known as optical flow. Well, who can, not optical, sorry, I want to follow a file. data telling, scale space, that's one, which actually relates to that one. Oh. Okay. So people worked about it in the beginning of the 1980s, something like that. There were subspace methods relevant for that one. I think it's going to be enough for here. But the question is, how did people solve those problems with segmentation when you want to do this for high-dimensional data, like medical imaging, medical data? Again, many companies I'm familiar with that started in the last 2 years working on exactly those problems for medical data. How do you do that? Do you know how can you actually do this segmentation? How can you find out what is the foreground and what is the background? What is similar to one another? What do you think? If you're given this task, okay, how will you do it? You know nothing about computer vision. A pixel will be segmented to another one if it is close by. So if it has, for example, a similar intensity, right? So here's the way. So this is how people started working on those problems. What is the problem with this concept? Let's assume that you have an image of a hand or whatever, of a tumor, and the tumor changed its color. I remind you all the tricks that we've seen in the beginning of the course, all the illusions. So I have a hand, some sort of a hand. And here we have a, I don't know, water. Here we have the beach, and someone put his hand in front of the camera. And over here, there is a boat or whatever, a boat. And somehow the color of the boat is exactly as the color of my hand, because that's what happened with the camera. And you're going to look at that image and say, okay, every pixel would have a similar intensity as the one next to it. Well, it's going to be exactly the same as that one, right? And you're going to segment the ship with my hand. But as a human being, we can actually, no doubt, know that there are two different objects, right? Even if we're going to look at the 2D image. What is known, the reason why we can do that in the computer is so hard for him is because what is known as the priors, meaning that we know that this is a hand, and we've seen gazillion different ships, and we know it's a different object, and we can separate between those two. So how can you actually write computer programs that actually can imitate it? So the first part goes to learning. Until today, we still see beautiful results coming out to solve those problems. Let's talk about another solution. What happens if you have not have one image, but you have a video? How can it help us to do the segmentation? So now I have a video of this version, and the ship is moving to the left. Yes? How can it help us do the segmentation on that image? Anyone? Anyone but you? Someone else? Yes.
You can just different things to see the motion of the things.
Okay. Great solution. He told me, okay, let's take 2 consecutive frames, evaluate the flow, and from that I know, for example, that that hand stayed still and the ship moves. What happens if my hand moves as well? Now we have a problem, right? We have motion for the hand and motion for the ship. Now I remind you that computer vision is not just an image, it's also a video. Okay? So now think that you do not have a 2-dimensional data. Now we have a 3-dimensional data, meaning I can do a segmentation in space-time domain. Okay? And now it's come a beautiful property, because in the space-time domain we can actually do this separation. Actually, I was consulting to a company that does another sports event, and they were, for example, what they needed to know, they wanted to extract the players from the foreground and from the background. And the problem is that if you have the close-up on the person, on the player, you have something on its background. So it's not going to be a player on the green grass. It's going to be a player on the, and behind him we're going to see the crowd, we're going to see the billboards, we're going to see other stuff. And it's super hard to do the separation. Actually, Adobe Lex packages that came out of Adobe have a very nice, cool new algorithms exactly to do that. What basically they're doing is look at the image, exactly as you just mentioned, finding the gradients. So they are finding the gradients of the object, as we discussed earlier. And when the gradients are low, for example here, they add to the gradients another weight that comes from the probability that there is or should be a weight over there, just because there are other consecutive sequences that over there is a gradient. And basically they add multiple filters and can actually solve those problems. And it all goes back to the filters, if you want, the gradients, and so on that came after this one. So segmentation, structure for motion. Today's results from Microsoft, that they actually get many, 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 many images of a place in the world, and you can actually travel in between. Look at the 3D structure for it from that one. So it's relevant. It's very relevant to stereo correspondence. But now we have multiple images. What is the problem with multiple images? What is the problem that you get so many images of the same object? Why is it a hard problem? Think about it. We thought about correctly doing just stereo. I'll show you how simple it is. But now we have multiple images. Yes?
Like you said before, you have to register the images. You have feature detection problems.
Okay.
Different perspectives.
Great. So basically we're saying that if we have a problem here, basically now we have exactly the same problem but multiplied by the number of images. It's more complicated than that. Think about it. Now, I do not get just one answer for each location. I get multiple answers. Problem number 2, something that I skipped about it when I talked about stereo. If I take 2 different images, right? What I told is I know that my camera is here, and I know that my camera was there, and then I looked at her glasses. But if I have all those images that people uploaded to the net, what don't I know? Which location did they took the picture from? So now we have a new set of problems. I have many images. I need to know what is their location. I even need to know which camera they use to know exactly what is the field view and so on for that image. And they do some cheating along the way, but it works quite well to do that. Combine everything together and you can actually construct the data. There is a line of algorithms called bundle adjustment. That basically is a huge optimization problem trying to solve everything together. What today Google and Microsoft have to face here is to actually be able to handle it in entirely different domains. You know how many computers, cameras, images are there on the net? That is billions, yes. That are familiar with Ramesh's presentation. We're talking about billions of cameras, billions of images, and we have many, many, many multiple images of the same location. How can I actually solve that problem? Now here's another problem that came out of this one. Let's assume I'm going to take an image of nickel here, and I would like to create this 3D structure. And I'm going to take the camera, I'm going to move it to the sides, and create some depth image of him. A side again, and do another image. And so on, I'm going to do a 360 degrees rotation around him to get the model. Who wants to do modeling today, for example? So many companies actually do want to have a 3D construction of the models. Okay, it's unbelievably how many companies are doing that. There is the latest company that I heard of, for example, is doing evaluating 3D evaluation of the ear canal, for example. But where I'm heading here is this story is, what is the problem? A new problem that we need to face when you're going to do a 360 degrees evaluation of nickel here model.
Actually put it never every location.
Let's assume I know the location. I'm even going to put nickel in the middle on the chair and rotate him. So basically I have a one camera looking at nickel. It doesn't move. Everything is the same. And nickel is rotated. And every time it rotates a little bit, I'll evaluate a new set of points for him. Even more than that, if I have 2 nearby set of points, there are very nice algorithms that people talk about here in chapter 12. How can I combine them together into one set? But think about a new problem that is going to come out of here. As nickel is finishing his 360 degrees rotation, what will be the problem? Okay, I think what you actually meant is the correct answer is that as I start to scan nickel, there are distortion and errors, so it's not exactly the same. But I fixed it a little bit as I do the rotation. But what happens when I just finish 360 degrees, and nickel is back in the forward position, and I build those points clouds as it turns around, it does not necessarily is going to fit. We're going to have a problem, because as I build this model as he rotated, we are going to do this stitching somewhere along the way. So people talked about new algorithms to do this full-time stitching of all the different images together. And then again, we have the same problem as before. We have too much data actually to handle that one. So this is basically what is known here as structure for motion. And it has very hard problem with that one. Motion is the optical flow. So for example, someone already showed us an example why it's important actually to do the optical flow for this one. Stitching in general is how to combine several images together, like panorama and so on. There are many, many problems, many ways to actually do this stitching, but let's put it aside. Computational photography. Gordon gave a talk last week, right, John?
Yeah,
okay. So for example, light field is a great example for computational photography. Okay, so we want to alter the hardware to get more information. So it's, for example, from the light field, I'm sure that Gordon told you that you can actually do a lot of tricks. We can do refocusing after you take the image. We can actually evaluate the depths out of that one. Now think it's a beautiful property. I told you how hard it is actually to extract the foreground from the background. But if I can actually change the camera a little bit and get the light field out of that one, we can actually do an extraction between the foreground and the background. So computational photography is all about that. It's being able to manipulate the hardware and the software as well. Stereo, we'll talk about 3D shape. Okay, so reconstruction is just one property. Other properties that came from 3D shape is actually to be able to learn deduce something about the object themselves. Image-based rendering. For example, what we can do out of that one is change the viewpoint of an image. So let's assume that I have two images of, again, let's take nickel, for example, from this position and from that position. But I would like to make a virtual tour around nickel, for example. So if I had a 3D structure, okay, if I knew what is the 3D structure of this room, it will be quite easy. There is a very cool trick, for example. You can just take the Kinect, download what is known as, for example, the Kinect Fusion. It's a code, as it is. Run it on your computer. It basically allows you to take the Kinect, move it around the room, basically. And if you want some sort of painting the room with the Kinect, and you get the depths and the intensity. And then you have the entire model. And now you can play with it, moving it around for all location and see what is going on. It's a very trick program, I have to admit, very cool program. And the only thing is that we really do not have to do that. If I want to get a high resolution version of this room without knowing the 3D from two images, so there are tricks to do that. So it's not going to be perfect, but I promise you we're not going to see the problem over there. We actually can generate new views for the same images. So people talk about it over there. And the last part is here actually recognition, which is basically split into two parts. One is detection, what is recognition? What is the difference? What is the difference in face detection and face recognition? Face detection is to
understand a class of objects.
Yes, or to see where is the face. Now, why it's a hard problem to see what is a face, right? Give it to a child, ask him, where is the face? He'll tell you, that one. Okay, how come it's so hard to do face detection? So actually people did it for so many years, face detection. If it's not written there, I think it goes back below the 1980s to go from the images and do face detection. But there was a breakthrough, or something in the early 90s, where Viola and Jones actually came up with their algorithm to do a very fast.
Eigenfaces in 91.
Ah, okay.
And then Viola Jones came in 2001.
Yes. So eigenfaces, it's a mathematical tool to take an image and split it into its own eigenspaces. Later on, it was used, by the way, for shapes. And Viola V. Jones basically came and said, okay, you know something? Give me many faces. Now, over there, when they say many, it wasn't millions. It was only a few, I think 100,000, something like that, faces. And we are going to learn different features for that face. And once we learn those features, we find out what are the most relevant features. And if I know what are the most relevant features, I'm going to take the image and just correlate, if you want, those different descriptors on the image itself. Now, over there, they use a trick known as an integral imaging, and at if we have time, we'll talk about it. Basically, it's a way to evaluate the sum of a square of points inside the image. And they did it super fast. Where do you use it today, by the way? Where do you have that actually use Viola and Jones? Camera, every camera. When you put your iPhone, iPad, whatever, and it basically have it automatically square on top of a face, not your face. What basically is going on behind the scenes, it's very fast algorithms dated back to the 1990s, something like that, to show you how to actually evaluate the faces. How about face detection? Now I don't want just to find a face, I want to find a specific face. So how can you do that? Do you know what are the best way to do face recognition today? Who shouted something? Okay, machine learning is the tool, basically. Machine learning is for me, is everything, basically. There are multiple ways to do the learning, okay? Now, what I wanted to talk about is like I say, what is what is the image, in some sense, that you want to work with? So I think that the best results come today, by the way, when you look at the iris, because the iris hardly ever change. It's rigid. It's almost, I don't know, constant, I'd say, and unique for each one of the different persons. I think that in the latest result, you will see that it's almost 100% okay, detection for the different iris algorithms. But the problem is the iris algorithm that I need you to come and look at some sensor, okay, and to be able to recognize you. And we would like to do that from afar. So now I'm going to take your image. Now there is a company lately that was sold to Facebook. Actually, I forgot its name, I have to admit. For face detection. Which one? Face something. I know there's a face in it, something like that. And over there, they have like a new trick of algorithm that evaluate the different differences between point of the face, and they use some correlation for each one of its own databases and do it super fast. And it was just sold, okay? All those companies that do the latest way of face recognition.
Yes, we'll do the face detection in the next
Okay.
1 hour. So we'll keep it as a mystery.
Okay. So at least for the face detection, you're going to see how it runs on the computer. But bear in mind, like I said, that the overachievers, I want them to do face recognition with that, not just face detection. Okay, so the idea now is as follows. Mr. Noah, okay, talks about some cool applications, and then we are going to talk about OpenCV, the different functions, and so on.
The general ideas. We can go back to one slide.
You can talk about this one or this one?
Of course, but I think one key message, and Noah will probably talk more about it, is 90% of apps that are out there are focusing on the block number 3, which is image processing. Mostly processing the images and applying filters and so on. And I actually just did a kind of a quick statistics this morning and looked at the App Store under camera and photo. And again, about 90% of the apps are just applying filters. They're cropping them, filtering them, rotating them. But as you can see, there's a lot of stuff that you could possibly do. But it's very rare for people who have computer vision skills to write apps. It's very rare for people to write apps to know anything about computer vision. And these two worlds have been somewhat separate so far. There have been just sprinkling a few apps in, I would say, kind of getting structure from motion, like we saw photosynth, or doing some computational photography, like SynthCam from Hawaii, but just one or two, just very, very rare to find apps that use anything sophisticated to do with most of these techniques. And as you'll see during the second half today, there are many apps that you can build on the fly, right here, during the next 2 months.
It's so easy to do face detection.
Face detection is a good example.
Yeah, face detection, object detection, tracking of objects. It's so easy to use OpenCV and just put it inside the app, and not just looking at image processing. It's so easy. Everybody wrote the code for you. Just playing with Lego. Just put everything together.
So we could just do a hackathon on 1 weekend. Do how many people do we have? 40 people. We can do 40 apps in, using one technique each.
Great.
Yes.
Thank you.
Yes.
So
doing the mic.
When you're doing structure from motion, right? The problem is you're trying to find uniqueness of 2 points. So, and your hardware is fixed. So what if you kept changing the focal distance? Would you get any uniqueness on 2 points?
The same is depth from focus.
Okay.
Yeah, so structure from motion, the problem is that you're trying to get uniqueness so you can calculate the depth, right? So, and your hardware is the same. So if you just take a single picture at one focus, the problem is you get some RGB constant, right? But if you kept changing the focus, which is constant hardware, could you get any uniqueness there?
There are several papers on doing structure from varied images on one focus. Okay, so there are several versions for those. Those I have seen actually know the parameters of the camera. Okay, so I know a priori what I should have accepted, what I should have received in each version. I assume it is possible to do that without knowing that a priori, but with additional information. I haven't seen a paper about that one.
Because I believe like the eye actually wobbles, our eye, it actually wobbles and helps with depth. So I don't know. I mean, I'm not changing the hardware. You could maybe spin the lens. Or...
Yeah, there are some techniques. There's an app called Twist Focus. I think we saw it last week. And Twist Focus actually takes a sequence of pictures. Maybe you're going to talk about that.
Yeah, Twist Focus is a good example.
Yeah, okay.
And
what was the name of that app that changed 2D to 3D?
It's not an app, it's a company.
Okay. Oh, what was the name?
Stargent.
Stargent. Okay.
Stargent TV.
interesting on that point. My past history is video games, and I've been at 4 different game studios, all of which undertook, as sort of a principal engineering task to extrude 3D information from 2D maps, before that started becoming widely available. It was the holy grail for game development because it gets you so much farther along in constructing 3D environments. So it's always interesting to see, how the same problems keep attempting to be solved until they're commoditized. And that's a little bit about what I'd like to talk to you guys about.
Well, if you don't mind, I don't have a microphone, but just introduce yourself in 1 minute.
Sure. So my name is Noah Heller. Right now, I'm CEO of a company called Vodo, which was backed by 2 Boston VCs and is still technically stealthy. We have an app that's going to come out around Christmas, and I'll show you guys a little preview of it today. Prior to that, I was an EIR that's an entrepreneur in residence for about 16 months at Atlas Venture, which is local in town. And prior to that, I ran Call of Duty as executive producer for about 8 years. And then if you go back a little bit farther, I was at Microsoft.
You worked with Laird?
Yeah, he was my first boss. He's now at Oculus. Yeah, Laird's a great guy. Is he? Really? Let's catch up later. It'd be great to see him. Say hi for me if we don't work something out. Prior to that, I was at Microsoft working on Xbox and Xbox Live, and I was PM and designer for Social, which wasn't called Social. It was called, hey kid, do a bunch of features, and we don't think they're important for games, like friends and leaderboards and matchmaking, because that's what wasn't important for games back then. And then prior to that, my first company was a WAP-based mobile game that was purchased by Microsoft. That's what led me out to Seattle in the first place. So I'm sort of a game guy, and I've always been, pretty technical, although it's been a long time since I've done engineering, and my bread and butter has been running engineering teams and helping things become marketable. And that's kind of tailing off of what, Ramesh was just saying. One of the biggest challenges, I think, in developing any kind of technology, whether it be medical, entertainment, media, office, it doesn't matter. If no one's using it, I think it's really unsatisfying. And that's kind of been a focus for me in my career. For Call of Duty, I got lucky and got hired at the right time, but my mandate at the company was to make multiplayer popular. I saw a lot of geeks like myself playing multiplayer, and I felt like it was going to go mainstream, and I did get lucky in that call, but we also did a lot of work on Call of Duty to make it mainstream. So for the last year plus that I was at Atlas and kind of searching for new opportunities, I was looking at a lot of different industries, a lot of different technology, because I wanted to get a step away from gaming. And I landed on sort of computer vision and image processing and machine learning. And my insight, which I think, again, you guys were just scratching the surface of right now, is where else have you seen such a heavy technical subject that's so deep and has had so many years of thought, and yet there isn't a great consumer experience out there? If you ask people on the street, what computer vision was, they'd have no idea. If you explain to them what it was capable of, maybe, a small percentage of people could tell you that face detection on Facebook is where they've encountered it before, but not really. And anytime, as a person who's kind of market focused and really, obsessed and deep believing in the fact that technology is powerful when we're all using it, I ask myself, where is the convergence of sort of image processing and ubiquity and cameras? And so that's part of what I'm going to go over with you guys today. When I was here a couple months ago, I made a comment that the Apple TV ports were unblocked, which was probably a security hole, but it let me share my iPhone screen, and someone's repaired the security hole since then. So I'm going to kind of hold this up, and I'm going to reference a couple apps, and then you guys can look at them in your own time rather than getting them up on the monitor. Sorry?
Do you have the dongle?
I don't have the dongle. I have a thing that turns this into an AirPlay station, but so it's totally okay. I'm not going to show you guys anything you can't see on your own. So, I want to start off with something that has absolutely nothing to do with image processing, but is a data problem. It's an app called Herd. Came out a couple weeks ago, and I love using this as my starting example because all Herd does is it's a buffer that runs on your phone. You can see a red line right there, and records the last 5 minutes of what anyone's been saying, even if the phone is in your pocket. And then at any given time, 4 minutes later, I can press this button, and it will save that as an audio clip to my phone, and then I can just kind of move on. And the reason why I think this is interesting for like the discussion today is, you've got a microphone, which is just a data collection device. In some respects, it has similarities with a camera. And these guys are solving one of the bigger problems, which is it's now cheap enough from a data standpoint, a technology standpoint, a storage standpoint, to just have audio collection running all the time. And it introduces a bigger problem, which is now I've got a 5-minute WAV file that I've got to parse through and find interesting information if I want to pick it out later. Hopefully these guys will be smart enough to start labeling the app with geolocational data or let me quickly annotate what was actually going on there. Some other apps that I think are scratching.
Now with Moto X, the audio is listening all the time anyway, so you don't even need an iPhone-like situation where you have to run the app.
Absolutely.
But it could be doing and now that we have co-processor philosophy coming up of, what do you have? Moto X.
Oh, there we go.
The co-processors that you have, right now we just have motion co-processor, but you will see there's a co-processor for everything. Yeah. So in PCs, as you know, there were a bunch of co-processors, even for floating point calculations, then for graphics, then for all these things. And now we have co-processors in phones. They're all going to offload this extra work. So you'll see more and more sensors on all the time.
Yeah, that's one of the interesting points here. I mean,
is there a trend for that? You see?
I think it's turned off, and I can say, "Okay, Google." Okay, Google. I forgot the command. I think.
But this trend of co-processors, are you seeing more of that?
I tried it when I first got it. I remember. I think it was okay, Google.
I think it's just Google.
Absolutely, where we're headed.
But it does work.
So,
I'll Google right now what the word is.
So think about like sensors and cameras, right? I did some research with a company that's putting in multiple cameras into a car, and they're going to use, sort of a volumetric shading meets computational stereo to try and let you do things in your car that are kind of interesting that I can't talk about. One of the reasons why it's possible to talk about that with car companies is because the lenses cost maybe $2, the sensors cost maybe 50 cents, and they're getting cheaper and cheaper all the time, which means they're going to be ubiquitous. Like, does anyone in the room doubt that, let's say 20 years from now, the walls in here will be just littered with cameras because it's cheap to do, and there'll be a reason to do it, and there'll be a network on the background. The interesting consumer applications will come out of the idea of I want a shot of Noah, and the best camera looking at him is up here because, again, it was cheap to put cameras everywhere. And so one of the questions I always want to ask myself is, what happens as technology becomes more ubiquitous? So a couple more examples of what's sort of interesting and exciting to me, and then I'll tell you where I'm going with this. This is Pixter, P-I-X-T-R. If any of you are single, you'll like this app. These guys just moved from Israel.
You can stand behind it and you have a live camera.
The webcam is showing that.
Oh, cool. That's good. I'll hold stuff up. So this is Pixter. Pixter is a bunch of guys who are, CV geeks. They moved here from Israel, and they've just changed the UI. What they do, and the reason why I mentioned it's good for dating, is they will go through a picture and they will make you more beautiful. So I happen to have a picture where I was lucky enough to meet the person on the cover of the Victoria's Secret catalog. Don't ask how. So watch. This is me and her. I got lucky that she'd hang out with a schlub like me. I'm going to press the wand button, which is going to perfect the picture. And you can see they have a little UI here where they show you they're detecting a face. Now they're going in and cleaning up my skin. And apparently my face is a little twisted. It's kind of hilarious how much they fix her, actually. And so I sat down with these guys and I talked to them a little bit because they're local now. Now they're adding clarity. Now whether the output image is truly better than the other, I don't know. Aesthetics are in the eye of the beholder. And these guys have gotten a little bit too narrow. If no one promises to repeat this, because I don't like to talk ill of other companies, but by their own admission, the only people using this are people using like Tinder or Facebook for dating or things like that. Because the only place you can really get away with actually changing your face, even if it's subtly, and like live with yourself as a human being is probably when you're dating, right? Another app that's kind of been limited in scope, right, is this one. This one's been around for a while. I would say this is probably the first CV app I ever saw on a mobile device. It's called WordLens. Some of you are probably familiar with this. Man, how am I going to demonstrate this? Who has a piece of paper with any bit of writing on it at all?
Make the window smaller so you have other text on the screen.
Oh, I'm just going to hold a piece of paper behind it. Just any piece of paper. It can have any text on it.
Print that text, you mean?
It should have come with props, huh? This will work. Okay. So what these guys do, right, is they recognize text. This is interesting. Okay. And you can see, assuming I can get the clarity right, which is kind of hard to do upside down and backwards.
Real-time translation.
They're real-time translating this from English to French, right? And what's more incredible, and again, could someone hold the phone here actually just for a second? I just need one pair of hands. If you can hold this steady, because my hands have had too much coffee. And then let me just move this back and forth to get it in focus. Come on. Okay. So what you'll notice is they're actually even making an attempt to match the font and the size, right? And they have a whole bunch of languages in there. By the way, if you ever travel to Europe, like this is a godsend just to read a menu. It's awesome. Now what it is it's also $1.99, maybe a language, and you pull it out once when you go to Europe once a year. It's not actually changing society. It's just a little tool. And so the question is, like, how do you actually make an impact on society? You know, no one's here because they want to make something that's used by 5,000 to 10,000 business travelers. Like, that's lame. You guys are smart enough to develop something deeper. So I'll tell you a little bit about what I'm developing, and then I'll kind of lead this all into sort of my thoughts about where stuff is trending and what led me in that direction. So I'm working on an application called Vodo, and again, appreciate if none of you tweet or blog or anything about it, because we're just not announced yet. It's coming soon. Oh, we have a live stream? It's called VidPhoto. My name is Nick Jones.
Let's call it something else.
And it actually is called VidPhoto. That's our stealth name. And I'll show you a little bit of it. Okay, who's going to be my victim? You looked at me and made eye contact. I'm so sorry. Okay, give me a little bit of a wave or something like that. Now turn your head a bit. Okay, perfect. So what we do is we go through video, right, and we start looking for frames of novelty that show high delta from each other. And so we present those as sort of, I wish I could call them keyframes if that word wasn't taken already, but key, lowercase k, frames inside the video that kind of show, and it was much faster than that, I just talked too long, that kind of show moments we think are interesting, right? So we will get the smile. Oh yeah, duh. Like we'll go up to the smile, right? You know, we'll go down. Oops, hard to do this upside down and backwards. What do you know? We'll go down to the hand wave. And importantly, let's say you as a user are looking for a hand wave. Like that's actually the image you wanted to get. You know, we'll let you, I think it's double tap in this build. So if you see the stack of photos sort of expanded, and what that did is actually it was a little local image processing we did where we were matching pixel comparison and saying, okay, what other images look like this, either temporally or regionally throughout the whole video. So if you know you're looking for a hand wave, you can find it again. You know, we had a little bit of an insight, which is it's exciting and interesting maybe to be able to find stuff quickly and locally. And what does it mean now that, you know, video is going to be on all the time? You know, the reason why I had you rotate your head, I won't show it here just because it's a little harder to demo in a clear way, but it gets to the point we were just making in the previous lecture, which is this as a face, a pure profile, is a much harder math problem, right, than this as a face, you know, fully forward. But when you've got video as your source data, you can track this image, read it through the frame, and still know that this set of pixels is probably a face, even once the eyes have completely disappeared. And so there's some insight you can get once you start looking at image problems as data problems, which is one of the things we've done. We also have a little bit of a social experience that I can't show you yet until the app is out, but basically we asked ourselves, what if we get really, really good at image categorization? What does that mean for an application that everyone might want to use? So for example, what if your smile is the smile you're willing to publish, but the photo I took of you has a different smile and I'm willing to publish that? You know, what if my picture of you gets more likes than your picture of you? What does that mean from looking at the photo from a spectral analysis standpoint? You know, can we make you a better photographer if the bar for being a better photographer is a photographer who's more shared or more respected or more liked or whatever metric you want to use? You know, rather than just a clear, bright picture with high color saturation or whatever a computer might do, completely unassisted from any human input. Basically, how can you turn social into kind of a machine learning experience? That's an interesting place we're investigating. And so, we'll be out in early December, and once that happens, I'll toss a note over to Ramesh, and love it if you guys can download it because it's free, and the more downloads, the more chance I have of not eating ramen. So let me close out with talking a little bit about where I see things going. And again, I'm probably more of a layperson than any of you guys, given that I'm the non-technical person on my own team. But I have some observations as someone who's just obsessed with this idea of ubiquity, right? One of the things that has been interesting to me is that because cameras are getting cheaper, before the fundamental nature of the camera changes, I love light field cameras. Like, I got to meet some of those guys very early on. I have no doubt that the day before we'll see a consumer light field camera, we'll see 1,000 cameras, on a device or on wearable clothing or clipped all over our bodies and rooms everywhere. Because the first thing manufacturing does is it goes cheaper and cheaper and cheaper, and then ubiquity before it goes to a new paradigm. Wearable cameras are very interesting. I'm a backer of that Kickstarter project, and I just can't remember the name this morning, but it's a little clip-on badge that takes a photo every 30 seconds. Thank you. I don't think they've shipped yet, but they will soon. They're only taking a picture every 30 seconds because the battery can't support video running all the time. Very interesting to me to think of the idea that anytime you're talking to someone, you're recording all the time. I spent a little time with a couple of the Google Glass guys in Boston, and one of the things they said that just struck me was the most useful application is the fact that you have a record of what you're saying all the time. Think about that Herd app and how it changes society when you're always being recorded. Privacy is absolutely going away. I think we all know that. It'll be interesting to see the societal taboos that spring up around it. Anyone here a Snapchat user? What happens when you try and screenshot in the earlier versions of Snapchat? I know they've shut it down now. Send a notification to the other user saying you tried to screenshot them. They basically notified the other user you violated their privacy. Like, think about that. That's the start of a taboo. It might be 20 years from now we have no privacy at all, but when someone knowingly violates your privacy, that could be a crime, even though we have no privacy all the time. The other thing that I think is more important, though, for this class, and honestly is a problem I'm dealing with right now, and is about data. The problem with cameras on all the time, the problem with higher resolution cameras, the problem with things that are picking up light from other spectrums, or is the fact that you have a data problem and sifting through the data is really, really difficult. One of the things I think that's going to get interesting is the idea that a camera and the processor will become very separated. There's no reason it has to be on your phone. It's just on your phone because you carry a CPU with you or a GPU with you all the time. Why shouldn't I be able to hit some local network of all the CPUs and GPUs available to do some heavy lifting on an image processing problem rather than relying on specialized hardware? Now, mind you, A7 chips, motion chips, specialized hardware is coming, and it's going to get very good and very fast, but that's sort of the next 5 to 10 years. What's the next step beyond that, when it's more important to get the image quick rather than go up to a cloud and wait for it to come down again? One of the reasons why I'm focused on video is because I always try and think of source data. If I have to take a great photo of this room, I will bet you 9 times out of 10 I will take a better photo gathering more data and sifting through it later than trying to get it right at the right time and hoping that everyone was posed in the right direction. And then this concept of source data, I think, is going to evolve over time. What is it really when you can take a video, you can take something that's very, very high resolution, and you've got audio in there, you've got pictures in there, you've got 3D data in there, you've got video in there. Like, what does that mean to the future of a society when there's this concept of source data and then output, which is video or photo or audio or holograms or whatever? How does that start to change things? And who's thinking in terms of source versus who's thinking in terms of output? These are some of the questions I ask and wrestle with. So anyway, to sum up, all I would say is, first of all, if you guys have any cool ideas for consumer CV stuff or read interesting papers, please feel free to send them my way. But more importantly, as you guys think about what you want to do in your career, I would stress you as either creators or scientists or developers or anyone else to focus on what gets your technology used. It's no fun at all to build something that no one uses. I've done it before in my career. I'll never do it again. And that's been kind of the razor I've applied to the way I think about CV today. Thanks.
Okay, just 1 second. We're short on time, but now if you can give me like 2 top misconceptions that programmers or technical guys like us have with respect to how consumers think about it. I know the one of them you have told me about is photo versus video. Can you give me like top 2?
Yeah, I mean, first of all, everyone knows this. Yeah, everyone knows this, but we should all tattoo it on our brains. Like, consumers are really, really dumb. And I mean that, and I love consumers, but they're really, really dumb. If you send someone a piece, the UI I just showed you guys is about 5 revisions old. Like, we tried everything to kind of create a new paradigm, and you can't hand it to someone and watch them play with it and see that they understand anything. You put a button that says OK somewhere, and someone will click all around it. And so one of the challenges, I think, when we start thinking about how to build something that wants consumer appeal, or even if you're building something for doctors, and doctors are not as technical as you are, realize that a big piece of your development process is user experience and standardizing it so people use your deeper features. One thing I heard from a friend of mine who works in travel, you probably wouldn't believe this, but if you go to like Kayak or whatever all the other travel sites are, maybe 5 to 10% of the population ever changes any of the settings other than the date they're traveling. No one clicks on nonstop. No one clicks on show me cheapest, show me best, put on this airline. It's a very small segment of society that's actually willing to do the tweaking of that tool and get into basically the preferences of that tool. I bet you everyone in this room would be willing to hit those things. So now you know a big piece of data about attracting a consumer. You're not the consumer. So test, iterate, iterate, iterate. It's the only path to getting anyone to use your product. And most of all, like I go down to Newberry Street all the time, and I'll take my application and I'll find some tween-age girl, and I'll say, sorry, I don't mean to be creepy, but can you take my camera and take some photos of your friends? I'm making an app, blah blah blah, and 3 out of 10 just shows you what the good old millennials are good for. About 6 out of 10 will take me up on that, especially if their parents aren't there, and the cops haven't been called yet. That is so key to our development process. I've got some smart guys, and when you ask them what they would want to use, they're completely wrong. And that's not who I'm building for. Like, smart people.
Briefly about the photo versus video.
Yeah, photo versus video was an interesting sort of insight for me. It was a basic idea. If I had to sum it all up, it was if you want to take a great photo, like, use a net, not a hook. It was a data problem. And also get rid of this anxiety that the consumer feels when they're having to choose video or photo. All the cameras now have 1 billion settings that you can go through to change what your camera does. And I would bet you that, again, 90% of consumers never change what it's doing. So imagine you're a dad taking your first steps, or you're out on a date and it's your first date and you want someone to take that moment. Are you going to trust that the shutter button is going to be hit at the right time? But are you also going to trust that the video is the right quality? Like, that's why I keep coming back to the idea of source. All I want to do is have a consumer say, capture this memory and let smarter ways, divine what they actually want out of the moment. Fair?
Yeah,
Okay.
so one of the things Noah told me was that actually when he did a survey, most consumers don't understand that a video is just a sequence of pictures.
Oh yeah, that's another. Try it. Try it on family members who aren't that technical. Ask them if they have any idea that a video is, a series of photos and audio track, right? Which is essentially what it is. They won't know the word frame, so you can't use that word. And even once you show them, if you take a frame from a video and you show them that, and you're like, here, they'll be like, oh, you took a photo. Like, they don't really grok the idea that it's one and the same. And so it's very important as technology developers that we always put ourselves in the shoes of those people and try and understand what insight that gives us.
All right, thanks a lot, Noah.
Cool. Thank you.
So, here is the outline for the next hour and a half. I'm going to do a very, very, very short introduction to OpenCV for the next something like 10-15 minutes. Then we're going to take a short break. And when you come back, actually, we're going to start working. Meaning I'm going to show a presentation, how to install everything that we need. And we're going to give you some projects to run. And then we're going to let you do that on your computers. Now, did everybody downloaded the programs that we asked you to download? Everybody downloaded?
So fire up your laptop.
You can fire up your laptop. It's fine, okay. But if you are missing one of the files, come to us in the break. We have it on the USB.
Sure everybody's up and running with unzipped file, and they're running the.
So basically, what Ramesh is saying: check that you have all the code, unzip it, have the folders. What you need to check that you have Eclipse up and running, Okay,
How many of you have Eclipse running right now?
great. How many installed on the Eclipse the C or C++ ADT? So not everyone. Okay.
Do it right now.
Okay, so do it right now. Does it appear? The instruction appears over there, right? I'm going to. Everyone, please take a page. It's more than a page, like a small booklet. Okay. The pages is what we send you. It appears in Google Docs, and I think what John put online, also for the people over there. All the instructions appear there. The reason we printed it is just because it's going to be easier for you to follow the instructions, basically as it moves along. So just have one of those pages. Over there, you will also find how to add the C++ ADT to your Eclipse. Some versions of Eclipse, okay, already have that one. If you have a Linux or a Mac, I think you need to add it by yourself. I think the Windows version already has that one in it. Just to make sure, I know that you all downloaded the Eclipse, and you already did something with the Android. So I'm pretty sure that you downloaded what is known as the ADT bundle that has all the Android parts. If for some reason you have just an Eclipse, meaning that you haven't done anything with the Android, then the rest of this class is not going to be good enough. So please download or take from the USB from Daniel the ADT bundle for Android that comes with the Eclipse with all the parts in it. And if you already have C++, it's fine. Some version has it already and some do not. So you need to see that you have Eclipse, C++, C++, ADT for that one. The OpenCV 2.4, 2.4.6, okay, which is the latest one. You might have the 6.1. It's okay, but I have to admit that there are some bugs. So if you haven't downloaded it, use the 2.4.6 and not the .1 in the end again. And you also need a third folder, which is the native NDK. That's the third folder you need to have that one on your computer. What else?
Just say these booklets. There are 3 different types, and it's like so. Share. We didn't print it like that much. So
I see.
20 copies.
3 different.
So we are 20, so just share it with 3 people can show.
By the way, if you haven't programmed, haven't done any programming in your life, so please sit to someone who actually did it. Okay, so did some programming along the way. The rest shouldn't be that hard. Now, when you come back from the break, okay, then we are going to start working when you actually have the files. Okay, that's the concept. Now let's do a short introduction to OpenCV.
Why don't you just do a quick run through of, not run through, but just to make sure everybody has installed, unzipped, and indicated running.
Don't install. We are going to show you how to install the stuff. Okay, don't install it yet. Just have it on the computer. Just have the folders on your computer.
How many of you have a folder? But just to make sure who doesn't.
Who doesn't have a folder? One of them. I remind you, Eclipse. Install the C++ ADT on Eclipse. That's the second part. The OpenCV 2.4.6 and the NDK for OpenCV. So we need 4 stuff. Who doesn't have those 4 stuff? Great. Talking about the code, not the paperwork. On your computer. So you're going to join someone else, or you have your own laptop. You don't know. In the break, someone will come in. Okay? In the break, you're going to see that one. It's basically. Let's talk for 10 minutes about OpenCV. Then we're going to take a break. When you return, I might talk a little bit about specific functions, and then we're going to start with the installation. It's going to be a 2-part. In the first part, we're going to show you exactly how to install everything and run some of the apps on the simulator and on the Android. And then you're going to have like a mini lab for like 30 minutes when you are going to do that on your computers, and we are going to work in between you to make sure that everything works. Okay? So that's the outline. OpenCV. For you do not need to know how all the computer vision problems are solved. Someone did it for you. Okay? That is OpenCV. You can go for if you have time or if you wanted to break, just go to http://opencv.org. You will find a description, the functions, everything you just wanted to do to use OpenCV in general on your computer. One of the folders over there, one of the things in this site, it will go to an OpenCV for Android. That's what we printed here for you. The instruction. It basically tells you how to install OpenCV as it is and put it on on your Android computer, all the steps that are needed for that. And specifically, there is a part which is called native code, meaning, then I'll explain in a second where is it relevant, some of the application need an additional packages. For example, the face detection. What we are going to do here needs that there is extra libraries. And this is the NDK, the natural, the native part of the OpenCV. So what is OpenCV? OpenCV actually was released, it's a set of libraries, a pre-programmed libraries that actually use all those tricks of computer vision, from image processing that Ramesh said that 90% are doing that, to 3D reconstruction, through object detection, optical flow, everything you want, already written, implemented, and you can use it. When I say on a BSD license, meaning you can use it for academic usage and for commercial usage. So if you open a company, it's fine, you can also use it. Okay, so use it for companies. Now it's free, meaning you can download it and update it as, I don't know, as many times basically as you wish. You have interfaces for C++, C, Python, Java. Now that's the full part. Do you remember that you did a project on Android? That was the first or second homework. Now Android, all the GUI of Android is written in Java. Okay, now Java is excellent software. It's an excellent programming. No, not about it, it's an excellent language. But it's a little bit slower than C++. C++ have other advantages, and OpenCV was written in C++. It was not written in Java. And in practice, it means that if you're going to use OpenCV and your Android, then you need to be able to compile and use C++. But lucky for us, it was already pre-made for Java, which is ready for the Android. So if you just download the OpenCV libraries and put it in your folder, as we're going to show you how to do that, you can run many, many, many functions of the OpenCV. Different image processing tasks, I think also optical flow will work, and other tricks. Not everything that OpenCV has to offer. So it was written and optimized in C++. It had the wrapping to use for Java for Android, but because you want to use everything, then we are going to basically put the actual code of OpenCV in the system and use what is known as the native part, which is the second folder that we ask you to download, and then you can use everything, okay, including face detection and all the more complex parts. It takes advantage of multi-core processing, meaning that if you're going to open the paper that actually wrote how to do, for example, optical flow, and implement it yourself, it's going to be much, much slower than actually using the OpenCV. Okay, people spend so much time actually writing the code as best as possible. So because you're using the code of someone else, it doesn't mean it's going to be slower. Okay, I promise you it's going to be easier, and it's going to be much faster than you're going to do it yourself. 6 people have already downloaded it last time I checked, and the last version actually is 2.4.6.1, but I think that one is the stable one. So this is what actually the latest stable one that you actually want to use. So what do you actually find in OpenCV? So again, just go to that site. You can type it now as I speak, http docs.opencv.org/docs/tutorial/tutorial.html. And basically it goes over all OpenCV, different options in usage. It's exactly like playing with Lego. Okay, if you like playing with Lego when you're a child, you're going to love OpenCV. Basically it tells you, you have everything, just pick what you want and play with it. So it's divided to several sub-libraries. Now, once you include OpenCV, it automatically includes almost everything. And there are many tutorials. So just choose the tutorial that best fits your needs and start working or changing that one. So for example, we have the core part, which is basically defining the basic data structure. Remember when we talked about an image? Okay, how do I put an image on the computer? I know with Java there is a variables, a constant, a integer, a float. How do I use an image? So OpenCV has a module, has a basic data type called MAT, M-A-T. We're going to see that in all the examples. In that data type, we actually put an image. And whenever I'm going to use whatever software, for example, blurring, so I'm going to take a MAT, put the image that came from the camera, it came from a file that I loaded, and I just put it inside this structure MAT. And once it's inside that structure, I can manipulate it as much as I want. For example, we can run any function on image processing. For example, blurring. So Gaussian blur is so important that we just have a function for Gaussian blur. So you have the image, you put it in this MAT structure, just run a function called something blah blah blur, and it's going to get a new MAT variable that is called with it. So image pros basically is, like I said, we have many different modules. We have linear and nonlinear filtering. We have a different transformation. For example, resizing, affine transformation. For example, let's assume that you're going to do something with the image on the movie. You would like to, I don't know, to add a mustache or whatever, who cares? And it's running too slow. So you figure out, oh, okay, so I'm going to trick the system. I'm going to resize the image to 1/10 of its size. I still see everything. I'm going to calculate, do something on that small image. For example, find the location of the face. And then I'm going to resize it back up. And then I get all the information I need, but it will going to take me much, I don't know, it was extremely faster than the original version. So you can resize it. So use the function to resize. You don't need to do it on your own. There are specific functions relevant for video. For example, to do motion estimation. For example, you're going to write a program that whenever someone is smiling or something is happening to the face, then he's going to take a picture. Then you're going to run a face detection, and then you're going to look at the face. Look, for example, at the motion just at the location of the face. And if the motion is related to a smile motion, for example, then please take a picture. Okay? Then you can actually use the video streaming. Okay? You can actually run all those motion estimation code on that one. Background subtraction. So let's assume that you want to, again, to extract me from the image, and I'm moving or I'm not moving, and the background is unchanging. Okay? It's not changing. Then you can actually use those functions. Somebody wrote those for me. Now, calibration 3D, we're probably not going to do any apopole geometry here. So let's side. But you have the code. Meaning that if you do want to do something a little bit more complicated on 3D data, again, you do not need to implement nothing. Just use the code as it is, so it's a different library. Feature 2D, super important. That one I'm pretty sure that we are going to use. For example, as we talked about the CIF and the SERF. So everything is implemented for defining the descriptor. So you get an image into the system, it's going to tell you what are the most meaningful points, what are the meaningful structures. So now, for example, let's assume that I would like to find objects on my own. I can do that using those features. But it's so important and it was so relevant for so many people, there is a library just for object detection. So there, for example, I can provide different images and do the learning and tell him I want to find a specific object. So it basically has all the code that you actually need to do to find an object. So we have objects here. For example, let's assume I want to take an image just when I am in the image. So I can put my face in an object. Let's find me in the image, for example. We have different GUI, so user interface, it has its own GUI, so we can actually use for improved GUI than just the regular Android. And it has many GPU acceleration. I remind you that today all the cellular has like a small GPU in it. So everything is already working on the GPU, but you can actually use those specific functions by their own. For example, finding nearest neighbors and so on, but this is more complicated part. So if you haven't programmed anything in computer vision in your life, put it aside. Okay, the GPU part currently is not that important. So those skills for today. If you're going to work on Android, you need to know Java, but in a very basic level. Okay. If you actually did the first two homework and it was fine with you, then it's fine with us. Okay, it's going to be good enough. iOS, we're not working on iOS here. Now, if you were doing that one, you'll find out that it's going to be a hard task. They have Objective-C, which is an entirely different language. I got annoyed just because I played a little bit with the iOS. Yes, give me 1 minute. After that one, I go to the break. So OpenCV, I saw that some people work here with OpenCV. That's great, okay? So you're just going to need to show how to work everything on the Android. But don't worry. Okay, but the OpenCV, as I said, it's super simple in our case. Just take the parts together. No problem with that one. And C++ for native code, no one did it. We are just going to show you how to use it and run it, okay? So it shouldn't be that hard. And as I said, you need to know that you have the Eclipse, the ADT, the C++ ADT, the OpenCV, the native part, and the simulator we're going to construct with you, basically. So 4 folders. We're going to take a break. So if you needed help with any one of those things to be prepared, this is the time. So let us know. So see you in 10 minutes?
Yes. And is anybody having any challenges with installation or getting it up and running?
So you guys need 3 packets, okay? OpenCV for Android SDK. Okay. You're going to have to share 20 copies. Here's 2 or 3. We'll let mention the installation. Yeah. I don't think we got that one.
So I'm going to skip the second part that I wanted to talk to. We're just going to do the installation. So we have we will have basically an hour. When they return from the break, they will have an hour. So your demo should be something like 10 minutes, 15, no, it's okay, 15 minutes, something like that. And then you're going to ask them to do everything. Okay, that's the goal.
Victor, can you hear us?
Yes.
I think they need to unmute.
You guys might need to unmute. Hey, Victor.
My glasses.
Yeah, Victor. So yes, I owe you myself.
Okay.
Hello? Can you hear? Just
See them, but we don't hear them. Yeah, I muted. Can you?
hello? Can you hear us?
So can you guys say something? We want to make. We can't hear you right yet. We think you're muted on your end. If you can hear me.
Hello. Hi.
We see you. Live long and prosper. Star Trek.
I'm
We
saying
cannot
something.
hear you yet.
Once again.
Oh, now we hear you.
Now we hear you.
Okay.
So I noticed on the Google chat you're not typing anything. So I'm assuming everything is going well. On the Google Doc.
Your audio's okay?
The audio is good. Yes.
So we
Everything's
lost
fine.
you for a little bit. Did you watch on the live stream instead?
So, yeah, we were following the web link for the most, for the majority of time. Yep.
Is everybody up and running with the packages, OpenCV and NDK and so on?
So, who have it up and running?
What I had before was the
Okay, Nikhil, you have it. NDC.
Yeah, that's good. Yeah.
I assume you would have already downloaded that.
Well, let's put it this way. Some of us have it up and running.
Okay.
Most of us probably work through later.
You can download it right now in the next 5 minutes, because the second half of the lecture is going to be all about doing the actual programming on the screen.
Okay. So
let us know if you're having any problems.
Mm-hmm.
So yesterday night you got an email with instructions to download the 2 packages. That's all you need.
I just press this. I just need. I want to put this up. No, I want to put this. Okay.
Yeah. Can you camera so we can just see the whole room?
Could you plan?
Yeah.
Apparently not. Well, we need to make. Well, guys, say something. Wait behind this.
Okay. Or at least type your names in the Google Doc so we know who's there.
Okay.
Only see 3 or 4 people who have their names there right now. I want to know you're online and you're looking at the stuff.
Its URL is in Spot. Yeah. Let's open this one. Spot. I'll ask. Okay, yeah. I'll ask.
Ну да, идея хорошая, вот не знаю, как можно технически что сделать. Ну ладно, посмотри, просто какие разрушения есть. Ты можешь так посмотреть кратко, типа, есть ли возможность как-то легко сделать? Там, конечно, не только для этого класса вообще.
And say, I think it's supposed to download separate. There was a link.
У тебя точно, у тебя пиво. У тебя выпечка и хорошо.
I think only the first one.
What is the absolute thing? Is it like exclusivity or something? No, it's the end case, like how to compile, to be able to compile native SQL and inside Android. So what's the name of the NDK? It's in the email from the class. Oh yeah, yeah. I mean, we already downloaded. Like you said that I'm like really support. Eclipse, the Android SDK, OpenCV, are you using Mac or Windows? So Windows normally the Eclipse SDK comes already with the first one that right the file
Basically just make a flashlight app.
interface of the Eclipse to
Light on and off. And
meaning that they don't have to download. If you're using Windows, you don't need to download. And like what if I use like Mac? Okay, so Mac.
Second one was making sure the camera app had some kind of documents installed. So like turn on the flash and increase the contrast. That would be
And did you go to like install new stuff?
So no. Windows come.
Oh, the like this indicator underneath the development. Yeah, I was just well, how do you know?
I will say that after all,
Does anybody?
Oh yeah, like.
Does anybody need the link?
Yeah.
For that Google Doc.
So if you download.
Everybody has it.
Yeah, we downloaded the bundle for the last one.
Okay.
We'll tell you what's
I guess if it was.
I'm going to show them your computer.
Guys, could you check that in behind?
When do you do it?
Oh, the previous assignments you do it all in this thing. Oh, because you have any other. Is everybody has their both packages installed and ready to go?
You download it to your desktop or somewhere.
Nice. Any problems connecting with the Google Doc or?
So it's called
Hi, hello again. So what you're going to do in the next hour is going to be, again, split to two. It will take something like 10 minutes or 15 minutes. We are going to show you, okay, how we install everything. And then we're going to show you how to run the different apps, and we're going to show you a little bit about the code that we're actually running, what is going on. And then we are going to basically go between the lines and let you do it. So the first part, just look at us. We're basically going to follow the steps that appears in the paper, in the short version. And Ron basically is going to talk about what is going on, and Daniel here is going to do it here on the computer. So bear with us for the next 10 minutes. So hopefully we'll see how simple it is. Hopefully.
All right, so this is going to be, everyone sort of has a different version running. Different people are Macs and PCs. So this is going to be a little bit tricky, but just, again, just pay attention. The only thing that needs to be interactive in this first part is this first instruction app, okay? So first things first, in your Package Explorer on the left, you see all the files, all your projects you've done in the past. Okay. Package Explorer, right-click anywhere in there, and click New, and scroll down to Other. Okay, and if you see a C/C++ folder, raise your hand. Okay, so some of you do. The rest of you don't? Okay, raise your hand if you don't. Just a couple. Okay, those two who don't see it, okay, I need you to do this real quick before we get started. Go to Help at the top of Eclipse. Install new software. And in that field up there, you're going to type in the following URL.
Things come automatically with a Java, okay? Language object. Actually add the C and C++. Some versions come automatically if you download it with the C++. Others you just need to add it. For example, if you jump just Eclipse to do any programming and want to do C++, basically you're going to do it. Right.
So if you don't have C/C++, you need to type in that URL at the top plus enter. And then you're going to check box NDK plugins and click next and follow through the install process, okay? If you already have C/C++, you're fine. No need to do this. Got it? Cool. Let's just walk through this. Do you have this mic? Anyone have the other mic? Here's your mic.
And plugins, it's very important. Just
Hello, can you hear us?
Yeah, I want to transfer.
sometimes you don't have to do it. but
Hello.
Strongly recommend. Install it, just exit and start it.
Hello, can you hear us? Hello. Hello.
Yes. Hello. Skulltech.
Yeah, it's from Skoldek. Could you please show again how did you install it? Because we don't. So I mean the second option. You said that if you don't see it, go
Yes.
there and there. So could you please show it again?
Sure.
Maybe
Can you see? Yeah, Nikhil will also type it. But can you guys see? Can you see our desktop right now with the Eclipse folder?
Yeah, yeah.
So you need to go in your Eclipse IDE. Can you pull up the IDE?
Yeah, wait. It's
Okay.
machine. Wait.
You want to pull up your Eclipse IDE, go to Help at the top, in the top toolbar, and install new software. And then in the text field next to the Add button, you have to put in that URL, which Nikhil will type into the doc. No, different one. It's this one.
Again.
So if you don't have a piece of paper, all the docs are up here again. We're basically just walking through these docs. You're going to encounter some problems. You can try and follow along, but we're not going to be answering any questions until when you guys try it all on your own later. Okay, just watch for now so you know what's going on, and then you'll be good to go.
So first, I will. Can you hear me? It's okay.
Yeah. Yeah.
Okay. So first, as we said, you need to extract the NDK folder in somewhere, whatever you want. Normally, I put here in the same package of the ADT bundle, just to be easy to find. And then you need to go to your file system. Where is my? Okay, you can see it over there. And then, where's the properties? The screen resolution is bigger than imagine.
Right click here.
Yeah. Yeah, better. So you go to purchase of your computer. Try to and go to advanced system set. So you're trying to set the file. So different from Linux to Mac and Windows, but I will show for the Windows. So it's very much variables, and you need to add a new variable called ndk root. So this is just telling the system that you can find the NDK folder in where you place it. So go to your folder, the path.
Could you please also add it to the Google Doc?
So in Mac, this is going to be slightly different. Okay. Sorry, Skulltech. Yes.
Yeah. Could you please also duplicate it in the Google Doc, because we can see your desktop, but we cannot. The resolution is too low. We cannot see what is typed.
I can't hear.
They cannot see the screen because the resolution is too low.
Oh, the resolution is too low. Okay.
So Google Doc.
Okay, Nikhil will be typing some instructions in the Google Doc, but you can follow along in the tutorial document as well. Okay. All we're trying to do right now is tell our PC, Windows, where the NDK folder is. Okay. On Mac, we're going to add it a little bit differently. So if you set an environment variable on Windows like this, it'll be global and it'll be permanent no matter what workspace you add. On Mac, we'll do things a little bit differently. Assuming that you're going to keep the same workspace, we're going to add an environment variable to that workspace. Okay? And I'll show you how to do that. We'll just walk through Windows first, and then we'll come back.
So just to correct myself, so is this folder you need to put in the system path. So it's under the NDK, the folder that you extract. So just add this file path and click OK. So now the system knows where's your NDK, so you can call the compile of the NDK through the Eclipse. So now you can open the Eclipse. Yeah. One small detail: you cannot keep open the Eclipse when you're doing this file path, because I don't know if Linux makes sense. At least for Windows, you need to close the program to the program see the file path. So, like if it was already open, just close it and then open again. So here we go.
Do you know what's the name of the variable?
So it should be
indicator.
So the name of the variable would be an arbitrary action.
So in Mac, Okay? We're not going to be able to plug into Mac, but in Mac, you should be able to follow the instructions. So in Mac, a lot of the instructions are easier. So it'll be pretty trivial. But what you're going to want to do is right-click your project folder, okay? Any project folder. C/C++ build. You're going to do this? Oh, okay. Are you going to do this? I will import first. Okay, yeah.
So
okay, we'll do both. We'll do both.
So first I will just show you how to import the OpenCV in your projects. Actually, first you need to import the OpenCV itself for your workspace, just to see. And it's good that it comes with some sample code, so you can see how it works and how it's going to work. So here you just need to go to import, general, existing projects into workspace, and then try to find the folder of OpenCV that you extracted. So in my case, it's here, OpenCV. So you just need to click OK. Supposedly it will start to load these samples, and you can see here this is the library itself. So with this you can start to import and use code of OpenCV in your Android projects. We have another samples. We will show soon how to use, but for now, just click Finish, and it will import the whole OpenCV in your workspace.
Imports also the examples and also the library.
Yeah.
So until now, what we have, let's summarize. We have Eclipse with C++ in it when you download from the NDK. We have the NDK folder downloaded. We call the computer where you intentionally find it. So it's the first thing is you get in Windows. You can find the instructions for Mac packages. Elaborate it later. And now we import the library of OpenCV and all the examples inside Eclipse. And those are the steps they did until now.
So hopefully you'll see this project's imported. As you can see, probably a lot of errors too.
So on Mac, you're also doing these same things. What we're doing that's different on Mac is we're not configuring it as a system environment variable. Again, we're configuring it as a per project environment variable. So that NDK root thing that we saw earlier, we're doing that later.
So again, now you'll see the projects imported, but with a lot of errors. It's normal. Don't be afraid. We have this problem. We tried in different computers and we had these problems again and again. So normally what we'll do is only click in the right click in the OpenCV library itself. And go to properties that I cannot see here. Again. Here we go. Hopefully I can see. Okay. Can't see. Can't see. So the properties, and go to Android. So what's going on here? We're trying to compile the OpenCV itself, but the problem is that you don't have the SDK that was used for compiling in the beginning. So you just need to select the SDK that you're using, that you already downloaded. Just click OK.
Many versions of Android. 4.3, the latest one. If you're going, for example, to take your Android telephone and look at the setting, you're going to see either probably 4.2, 4.22, whatever. If you're going to do any OpenCV programming to a given Android, you need it to be into the right system. So for example, here we downloaded the 4.3. If you want to download other sorts of Androids, I'm going to show you in a second how to do that. So you need to mark the compilation ID for a given version.
So after you do that, it should try and rebuild that file for you. You can see this coming down in the console, and the error should disappear. Okay, an OpenCV library.
Sometimes happens that it disappear. This case is kind of a case, but normally, only with this will correct the OpenCV itself. But still have the problems in other parts. But the problem is the same. You just need to go here.
The library is compiled and is ready to be used. Now basically we want to show you how to do it for each and every one of those examples. Afterwards we'll show you on our own example.
Yeah. So if you go to any example and then do the same, go to the properties of projects and Android, you'll see this part that's using a lot. That's the OpenCV itself. So if you don't see this, maybe you have a trouble. You need to download the new version of ADT. Okay,
So basically, for every program, this is how we link our program to the OpenCV library. Okay, in the properties of the sample, you do the link. Okay, it's a dynamic link between our program and the libraries, all of those functions. And again, you mark the Android 4.3 here. We're going to compile it for the current version.
And hopefully, it would appear the error again. So now I will show some examples from. No.
You should have the simulators already installed. Raise your hand if you don't have the simulator installed on your ADT device.
Yes, the emulator.
Emulator, sorry.
Okay. So some of the parts of the OpenCV do not work on the emulator. Actually, you can tweak it, but it's not that easy. So for example, if you're going to do something with the camera, you can use the web camera, what I would strongly suggest, leave it aside. Just download it and use it on the regular Android.
So for now, we are starting to use the OpenCV itself. The beauty part of the OpenCV, as Dan said, you have like a huge Swiss knife in your pocket to do whatever you want. And also, the version on Android have some facilities that you can use for your project. So for example, Rohan showed you the programs to take the picture, and probably you made it. But normally, you don't have access for the video stream that's coming. So that's why the reason that normally you take a picture for your assignments, you first took a picture, then try to process. That's because Android tries to hide this kind of pipeline to get this information. First, because it's image data. Image data, we know that's really, really heavy to process. Even for Android, sometimes even for a computer, sometimes really heavy. For Android, more than this. But there are ways to get this. Normally, if you wanted to do by hand, you need to by native code. So you need to go deep inside the code of some parts of Android and try to get this information. Luckily, OpenCV people did it for us, so you can get this access. But I will just show some simple example how to access the OpenCV itself. So nothing really hard. You just need to create this function and import the OpenCV itself for your project. But you need to create this line. If you saw the tutorial that I sent saying using OpenCV, it shows this function. So what's doing here? It's calling the OpenCV for somewhere and you're saying like, from now I will try to use the OpenCV. And here, on this home manager connected. So you're trying to call the OpenCV in your Android, and when it's done, you can do some stuff. So here, what I'm doing, I'm just loading some image.
We are going to give you this template. For example, if you're going to do your own program, don't worry about it. You have something. We're just going to get this code, run that part, go to the lines that Daniel is now describing what's going on, and change it. Okay, so everything what is going on above and below that part shouldn't worry. Okay, we're going to give you that code, and you can also find many other examples.
Okay, so one really important thing for both your emulator and your device, you need an additional app. Okay, so there's a way to import it as a library and compile it all as once. You can use all of OpenCV's methods, but that seems to be problematic, and it's not the most up-to-date. So for the purposes of this class, on your device or on your emulator, you want to install the app called OpenCV Manager, okay? And so what it's going to do is it's going to ask that other app for the function. That way you always have the most up-to-date, current build, and you don't have to worry about any library compilation issues, okay? So on your phone, it's free on the Play Store. On the emulator, it's a little bit different. You have to do ADB install. So you can Google that if you really want to get it working on your emulator. But again, emulator, OpenCV is a little bit tricky. And we have 3-4 devices for you guys to use here. We'll pass them out after we finish.
So, okay. So now we can start to use the OpenCV, and as Dan said, it's some lines you can do magic. So here, we are loading an image in a mat format. This is the format of the OpenCV. It's like matrices with some wrappers. You can do more steps. So here, we're first we are just connecting a view to the image. Here we are loading the image from the resources of Android. And again, thanks for OpenCV, they made like a small function that can convert your resource in Android directly to a mesh. Yes?
If you have an Android, by the way, it's fine. You can use your own Android. I use mine. Okay? You do not need those extra Androids. For people who just have, a group of people who just have iPhones. As you can see now.
So we'll send you a link for it. Yeah, we'll send it out a bit. Right now, we just want you to watch.
So here I'm just loading the image and then creating a bitmap to be able to show you after in the screen. And then here's the magic. I'm blurring the image and it's one line. So as Dan says, you go to this package, image proc, that have a lot of functions to do image processing. So for example,
Image Pro, for example, is one of the packages of all the image processing functions. Just write its name, right? You will see a list of functions that you want to use.
here's box filters, the filters that Dan said, some have cannies to get, that's another algorithm to get edges. You have, well, a whole bunch of work, so you can try it after. And then, yeah.
Sorry, you should.
Yes, sir. So and then I will show the result here because we don't have that much time. But so oops. No. So sorry, I need to use the webcam, but here's the demo. So if you see this image slightly blurred, it's a little bit because webcam also, but also because we are doing image processing and blurring the image itself. And oops. And again, it's like a process of one line. You just need to call blur, and that's over. And that's over.
Yeah. So for Mac users, the environment variable part, I'm going to walk through that right now. Now that you've seen this first app, go to Eclipse. So at the top, you'll see your Eclipse file menu. Click Preferences. Okay. And then on the left, you'll see the C/C++. Click that tree, open that tree up. And under the build tree, so click build, you'll see something called environment. Yeah, well, they took the dongle. Yeah.
Oh, yeah.
Oh, yeah.
Exactly the same.
Sorry?
You do it here, it's exactly the same. You do it in most computers, exactly the same.
Properties?
Yes. Well, we have one up here.
Where's the environment? C++. No, very good. So where is it?
It's file. Yeah, I don't know where it is. There it is. So it's right here. We're showing you on the screen right now. C++ build environment. Okay, and here you can add your variable. So this will just
is that if you do it inside Eclipse, it's relevant for one project. If you do it in the computer, it will be relevant for all the files. Everybody will know that.
Right.
All different files, all different projects will know that files. It's better to do it in the computer. There is a way to do it in Mac and in Linux as well. But regardless, one of them you have to do.
Right.
Either doing that inside Eclipse for each project, or knowing how to do that in the actual disconnect.
So here you're going to do the same thing. Just press add, and you want to add as your variable ndk root, all caps. And as your value, you're going to point to your ndk9, ndkr9, right? Something you downloaded recently. So in my case, it's users, my name. I put it on my desktop, and I'm pointing to the root folder of that ndk we extracted last night.
Exactly the same root, the same file path that I showed before. And at last, to link yourself with OpenCV, I forgot to say this, sorry. You need to go to your project, properties, and the same place that I was doing stuffs. Go to Android, and here, libraries. So probably in your computer, you will see nothing, but when you click Add, it will appear the OpenCV project for you. Here, since I already included, it's here. We will make this open for you so play with this. And
so that's basically the final step to import your OpenCV library. So we've imported it into our project package explorer. You guys set it to Android 4.3, and now for a specific Android app, in this case OpenCV image process, we make sure that library is added. Okay, we right-click properties, and then in the library we add the OpenCV.
Yeah.
So you will ever give any course in programming, but you're doing it dynamically between the precompiled libraries.
So first thing we want to do is we want them to run face detection sample right.
Necessary steps.
So at least I'll just show you another issue of the OpenCV. As I said, you can, for example, use the OpenCV itself to access the camera and process the information. So we made a small program for you. This is the edge detector, and it's working in real time. So you can process per frame. Again, it's a class inside the OpenCV. We will make this code open. I think that's already open.
Yeah.
So you can just download and try it after.
And yesterday is 2 apps, 2 projects that you can actually import into your system and run them. This is what we actually want you to see if we can
Yes.
do that one.
There's one more thing that you should do on it. You have to change the code command.
Yes, we need to
Yeah,
right.
Right.
Linux and format.
So if you still see exclamation points on your files, which happens for some people, not for everyone, you need to go into
The main program that actually compiles the data has different names on the Windows system and in a Mac and a Linux system.
Good point. We actually forgot this. So Mac and Linux, you just need to take this out. .cmd. So for Windows, you need to find a function. For Linux and Mac, you don't have this actually.
properties of, you right-click, do properties, click C/C++ build, and then delete that CMD. That's calling the native, Windows CMD instead. That should eliminate all the errors remaining in your project. Yeah. Yes. So you'll encounter that. Some people it'll happen for each project. Some people it won't. So it sort of depends on your build.
So just to delete the whole line?
No. Just the ending. .cmd. The Windows version, the file is a .cmd in the end. And the Linux and Mac versions do not. They didn't do this right. And that's it. Now you can run everything.
Okay.
So the goal for the next 20 minutes, basically, is for you to do everything. So we are going to start from scratch again. Okay. So Daniel is going to start again from scratch, and we're going to state everything again, and you're going to do that without. Okay. So in the next 20 minutes, I want everyone to have a running app, either on his Android or the Android that we showed here, either alone or with a subgroup or something. I want to know that you can compile and run an app. Because changing it's going to be super easy afterwards for homework.
So after you get the entire environment set up, the first thing you're going to run is actually the built-in OpenCV sample. It's OpenCV sample-face detection. Okay, that should work for you right as default. You should just be able to go in there, press run, throw it on your Android phone, and you should see that working right away. Once that's working, then we can import the projects that Daniel has shown you, which is the edge detection, the blur, and you can try those out as well. Sound good? Any questions?
When Michael finishes, put his Android app and show us that he can actually find our faces.
Yeah.
That's the goal for the next 20 minutes. Everybody will have a hand up.
So collaborate, share, ask questions with your neighbors. We'll be running around helping you as well.
So let's make sure we get some group
Yes.
questions to see where everybody is. How many of you have made it all the way?
Already?
All right. So let's bring down the steps of how many people have. How many steps?
Okay, so let's start from the scratch. Let's start from everything from the beginning. Everything from the beginning, and every step that you're doing, you're going to stop and check everybody out with us. Okay? So Eclipse. Everybody install Eclipse? Great.
No, raise the hand.
Who didn't install Eclipse? Who didn't install Eclipse? Yes. Everybody has Eclipse. Great. Option 2. Let's see if you have
get my
C and C++.
secret copy. Yeah.
Delete the projects. Wait, and it's clean is not so easy.
It's not hard. So when you
Daniel is removing everything
right click
and
it.
starting from scratch.
So step 1, everyone has Eclipse. Step 2, you want everyone to be able to use C and C++. So the way to do that, we're going to go for, then I will show you in a second, new project, we're going to see that there is C and C++. So we're going to make sure that everybody has that. Everybody has that. Okay.
Wait.
Scott, do you have Mac or Windows over there? Everybody Windows? Don't know.
I think most
Okay. So let's do the verbal setup, okay, for Windows. There is the folder with the NDK. Everybody has a folder. Someone doesn't have a folder. The folder of the NDK, the native ADK. Everybody has it. Toltec, you have the folder, right?
Yes.
Yes, you have the folder. Great. Check where is you put it, either in desktop or downloads. You need to know the location of this folder, where you put it. Now we're going to go for Windows Properties. Windows Properties, and we're going to add this path.
Let me just go to Scratch again. Here, computer.
Computer. So go in your computer. You can see. Computer. Look, this is what you didn't see. Okay. Computer. Right click. Properties. Left click. Advanced system settings. Left click. Environment variables. Left click. People, this is where you add the NDK location to a Windows system. Everybody who has a Windows system, okay, this is the best way to do that. Windows system. New. Variable name. It has to be uppercase. NDK. Root. One word. And the variable name, you're going to put the location of the folder, okay, of the folder of the Android ADK. So we have the full path that you use it, backslash the Android minus NDK minus R9, okay, with the name of the folder itself.
Yeah, please. But no, I think maybe it changes a little bit. But it's the name of the. No, that's the name of the package. It's fine.
Ah, okay, what Daniel is saying is that if you download this package, you might have an additional letters after the R9. So check the name of the folder that you downloaded, and it has to be exactly the path with exactly the name that you downloaded. Great. Who has a Windows system? Windows system, put your hands up. Everyone with a Windows? Who did it? You can put your hands down. So everybody is okay with this step, right? All the Windows people are okay with this step. School Tech, fine? Are you okay with that one? Great. Okay. So now we can go back to Eclipse. Now let's make sure everybody has C and C++ on their system.
Yeah, for the path. No, for as a new variable. It's a new variable.
New
yeah.
variable.
No.
No, it's good. It has to be a variable because in the compilation, it's search for this variable. Yes. Great. So let's go for the Eclipse. So let's see if you have C and C++. Okay. Again, let's do it again. We're going to check whether you have C and C++. Go to New. New. Other. You go to New. Other. Check whether you have this line, C/C++. Everybody please check that you have this line. Let me know if you do not have this line. School Tech, do you have this line? Do you have C, C++? Everybody has it? Great. Everybody here has it? I assume everybody has it. Somehow, we do not see the screen anymore. Oh, great. Excellent. So now we have Eclipse. We have a global variable, okay? And we have the C and C++ version. By the way, if you have questions, you're feeling comfortable asking me currently, just raise your hand, okay? One of us will come and help you, okay? It's fine. Really, it's fine. Next step. You want to import the OpenCV, okay? So you went to File, Import. Do this from scratch. We go for right click, import, general, existing into workspace. Okay, and we're going to import the OpenCV, both the examples and the libraries. Okay, and then you need to select root directory. Then you're going to choose the OpenCV folder. That's the second folder you downloaded, the 2.4.6. OpenCV 2.4.6 Android SDK. Okay for everything. What you should see on the left, OpenCV library on the top, and the different samples and examples, probably with an X to the left. Who has this version? Who has actually? Who did it? Who did it? Those who do not raise their hand mean that they didn't do it. I remind you, okay? So again, please follow us. Let's do it again. Do it again. Do it with us, okay? I promise you, if you wait until you reach home to do that, okay, it will be painful, okay? Because we have a lot of errors along the way. So again, right click, import. Are you building it? Watch again what Daniel is doing. Right click, import. Again, the package explorer is empty. You do right click, import, general, existing project into workspace, and you choose the folder of the OpenCV 2.4.6. Please do that. OpenCV 2.4.6/Android/SDK. Okay? And you import everything. Push finish. Okay. So currently, we should have OpenCV not compiled to your computer, C, C++, and the global variable, everything should be ready. Excellent. Now let's compile OpenCV. You go for the OpenCV, right-click, properties to the bottom, Alt and Enter. Then you go to the Android. You see on the left, we have resource Android. You should see at least Android 4.3, at least. If you want a different version of Android, okay, then raise your hand and someone will show you how to do that. There is a place here that you actually change and download new versions of Android, or old versions.
Yeah, how can I download the older version?
Okay, let's do that for everyone. We'll see. On the top, you'll see there is a Android SDK manager. You see over there? Press that one. It's just below the word navigate on the top. And it will pop up soon. See, it's stuck with the building. Okay. And when that Android SDK manager opened, okay, then it's going to show you that you can download and install different versions of Android. For example, let's assume that you have a 4.22. You go here to 4.22, mark the left for everything, and just install packages. What will happen is that on your computer, you now can choose to compile it to which versions of Android. Okay? So we'll have all the versions over there. Let's skip that one. Okay. Now we would like to compile the OpenCV library. To actually be able to compile it, if you are having a Mac, we want to change the compilation word. We need to remove the .cmd. So everyone who has a Mac, please focus on the next step. Go for OpenCV, double click, right click. See, you're right. I'm sorry, you do not need it for the OpenCV. Mistake. We're going to do that afterwards for the tutorial. So compile the OpenCV, but we would like to see that you do not have an error version on this OpenCV library. So just compile the OpenCV version, and let's see if everybody were able to successfully compile the OpenCV. Then can you do a clean and recompile so they can see what's going on for the OpenCV library? Can you do clean and recompile? I think it will. I will not remove that one. Clean will allow you to do that. We are just cleaning our system to do that step again. Okay. Who compiled the OpenCV? Who successfully compiled the OpenCV version? Only part of the people. Who wants to compile the OpenCV version and didn't do that? Okay, did you get different errors or you do not know how to compile it? I see. Okay.
What's
Did
the
you?
problem we're facing before that? You don't need to.
Yes, for this step, you just don't need anything, okay? So those of you, like I said, those of you who still want to compile, okay, are willing to do the effort, okay, then please raise your hand and Ron will go with me and see what is going on. But the trick is just to import the files. That's it. Import the OpenCV files and go to the OpenCV line and compile it. That's it. For compiling, you can choose right-click and do compile, or go for, as it is picked, you see it is a little bit blue, go for project, build project. That's the way to compile it. And if everything is okay, but you should see many errors, and on the first row of the OpenCV, you should see that it's clean. No X, no red X on that one. Skaltech, everything is okay? Do you have you imported everything? I assume it's okay. Great. Now let's try and run the face detection. So, what you would like to do, not running yet, to change the compilation command for the face detection example. If you have a Mac or a Linux, you need to do the following steps. If you have a Windows, don't do anything, just watch. So Mac and Linux, you're going for the face detection. Right click. Let's go for properties. Make sure that you mark, for example, Android 0.3 at the top. Mark that one. To make sure that you have that line, the Java line, the OpenCV library 2.4.6 linked. If it doesn't, if you see nothing in this folder, in this window, press add and add that link. Okay? You must see in the window the Android 0.3 marked with a V. Marked, and you have some line linked for the OpenCV. Okay, now we need to change the command of the program. Go to the build. Again, we are still in the main menu. We go for C++ build on the left. We go for the build command. Only the people with a Mac and a Linux. Please remove the D and C dot. Just remove those 3 or 4 letters. If you have a Mac or Linux, you just need to remove 3. Keep it like that. We are not going to do that. It's a Windows system. Don't do it OK. Yeah, that's CMD. And then we need to press OK. The system build. What you should is build finished. And on the face detection example, you should see that it's cleared without any red X. Now it means everything is great. You can now download that software as it is, which we are going to do shortly. So I need to see how many people are still, I don't know, struggling with that one. Struggling. Okay, let's see what step do you have. Do you have the OpenCV compiled without any X? Right, so all of you have problems. Do you have OpenCV? Who doesn't have the OpenCV library, which is the top one without the red X? Who doesn't have that one? You still have an X. It's fine. Excellent. Next step, we're going to go again for the OpenCV face detection. This is something we're going to do for homework afterwards. We're going to check. So we have face detection. The 4th row, you have a Windows version, right? So the only thing we need to make sure that you can actually link out of the library. Right-click, properties. You can do it. Right-click, okay? You do not change anything in the build, so you just go to the resource Android and make sure that you see this page. Android 4.3 is marked, and that you have a linked something here. It's written over there in this window. This is what you see? Excellent. Press OK. The system automatically is supposed to run the build, and you should see build finished, and the red cross is off. You have an error. Did you change the properties of the NDK that we showed earlier of the system, where to find the NDK? Again? Okay. It means that you didn't add to the global variables. What you need to go We're going to do it again. Daniel, please go to the Windows and edit. People who reach that point and still get errors, it means that they didn't add the NDK properties correctly to the system. Which means, again, you go to the computer, my computer. Everybody who has a Windows. Everybody actually? Yes, everybody who has a Windows. You go to the computer, right-click, Advanced System Setting. Yep. Environment variables. Did you add it? If you did it, you probably misspelled the folder name or location. If you haven't done so, then please add it.
Hey, hello, can you
You
hear
cannot
me?
find the
From
compiler,
Skoldeck?
okay? Because you didn't find this
Hey,
variable.
hello? Hello? Can you hear me? Hello?
Just make sure that you're adding the entire URL until here, until the root folder of NDK. So you need to put the root folder of NDK also in the file path.
Hey, hello, can you hear me? It's from Skoldeck. Can you hear me?
Yes.
Yeah. So, well, actually, that's very important point. That when you use the path for this library, you need to avoid spaces in the path, because if you have spaces in the full path of the folder, then it will work incorrectly. It could not work with the path that contains spaces. So that's what we have right now. We use the path with spaces, and it cannot work with that library.
Yes, there is a remark in the pages that you printed that you please avoid it. There is a way, a go around, so it will work with spaces, but it's more complicated. Okay, so what I think is a good remark. Maybe that you put the folder, the Android NDK R9, in another folder that has spaces. Please avoid doing that one. Okay, what Daniel is showing you is you do not need to click the location of the folder. Just find where you put your folder, the Android ADK, go to the top line, copy paste that one, okay, copy it, and paste it into the new variable location. Okay, NDK root. Who tried to do that? Who haven't succeeded? Okay, still have problems. 1, 2. Okay, did you try to change the NDK root? Change it to the correct one? Still a problem?
Did you try to close once the Eclipse and then open again?
Currently, what it is saying is now that what you actually did is after you added the variables, did you close the Eclipse and open the Eclipse? And you still have the same errors. We come see that in a few minutes. Okay? So for the next few minutes, let's talk about the actual code. Okay? So I think that most of you have a running system, basically. And Daniel, there is a reception hours or something like that for the people here? Do you have reception hours? We don't know. Ramesh, do they have reception hours? They want to come with the laptop to the people for help or something? Okay. So basically, people who didn't reach this stage, in general.
What did we do? Tuesday 5, 5.5.
We also have some today.
Oh, that's right.
Some today.
Because for the light field assignment, we have open office. Today at 5 p.m. again? Today at 5 p.m. Remember, there's always free food.
So basically, if you haven't reached the stage when you see that the sample of the face detection is without any red cross, so if you haven't reached this stage, please come to one of the reception hours, okay? And Ron or Daniel or me will show you probably how you go on your machine and see what is wrong over there, because this is basically the last step to do to run this system, okay? There's nothing more over there. And the only thing that is left is just to physically connect your Android into the system, and that's it. Now, no, I'm just going to open OpenCV docs. Okay, the last thing I want to show you is that what I really think that you want to do is go to the site of OpenCV. And in that site, in the site of the OpenCV, you're going to see many, many samples, examples of OpenCV. Over there, you're going to show you that there is an OpenCV for Android. OpenCV. What? Okay, In the OpenCV, you will find many, many documentation. Okay, go for the documentation, for example. Okay, just press the documentation. Okay, and you will find many examples like how to build, what to build, different versions, different functions. Let's go for OpenCV tutorials. Yes. In the OpenCV tutorial, they will go, you can actually find each and every one of the different functions in the different libraries. For example, let's assume they would like to do image processing. Then there is a list, reference of all the many functions over there. But I strongly suggest to start with the tutorial. So for example, let's go here for smoothing images, for example. Press for the smoothing image. Then you will see an explanation a little bit about convolution, how it's actually done, but to show you a little bit about the mechanics of the convol, the kernels that we even discussed a little bit. And you go down and down, it basically explains what is going on, and you actually get the code. And you can actually use this code, okay, to run the OpenCV. If you want to know a little bit more about OpenCV and the different functions, this is an excellent way to actually start looking at the code and the functions. If you'd like to play with the Android, for example, to find different examples from the Android, you can go for Android for OpenCV for Android tutorials. Yes. Show you how does the tutorials for the Android looks like. And again, just start with something. Now for the homework, there is 2 links that you put online. One that does the blurring, 3 actually, right? One the blurring, one that actually does the edge detection, that's what Daniel wrote, and the third one is going to be the actual face detection that you see here, and we want you to run it. So, and I really strongly suggest that you're going to take that version, that template, run it as it is. Okay, so basically you see as you're going to move your camera, it's going to find the faces. Take this code. There is basically over there. Only one line to show you that he has the classification of the face detection, and just change your code, whatever you want, on top of it, below it, okay, and play with this one. Add whatever you want to that one. So don't start from scratch. Don't do a new project from scratch and start a program in Android. It will kill you, basically. Okay? So get one of those applications that is running and working on your telephone and just change it. So in the Google Doc, I think you have 2 links. Run it in the Google Docs. The list of the apps, Daniel's apps. You're going to have... Okay, it's on the class. Okay, great. So basically you have 2 packages. You just want to do an import for them, compile them, run them, and see that they are running on your system. If you got that part checked, then great. And you can actually start working on your own app and change it a little bit more. Never mind. Never mind. Ron, we have something like 7 minutes. By the way, question. I think that right now is the best time to ask a few questions if you want about this tutorial or anything here about computer vision. Let's see. I think we start from the... Who has a running version on an Android? Cool. Tech. No one has a running version on an Android? Who has a running version on an Android?
Who has a running version
on a real Android, not an emulator. Yes, who had a running version on the real Android, running the face detection on a real Android? 2/3 of the face. Okay, that's great. Who have a running version on the emulator? Something on the emulator. Okay, that's fine. Let's see, what do you want? Who is able to compile? Okay, only compile the face detection algorithm. So just compiled. Could it run? No, it didn't run. I saw what happened. Didn't run, but compiled. Okay. Who are able to compile the OpenCV library? 1 or 2, whatever. I see. So basically, those are the steps. Okay, it's fine. So if you have reached the last step of the face detection, really do that at home. Okay, get your Android with friends Android or whatever to run the face detection. If it's not running, please come to the reception hour because come to them at 5 p.m. 5:30. Okay. I want to show them. You can show them the app, okay? Because the homework and everything you're going to do from this day on, okay, is going to relate to that app. basically. Okay.
With this app, do all kinds of interesting things. Simple the camera first.
Next time, talk about the final project.
Light fields if you want, face detection. As time goes on, we will build an app to look at your skin, build a health app, we'll build a web crawler that will crawl on the web and show on your phone. So we're building a series of apps.
Well, yeah. So Daniel, the two apps that Daniel showed you, smoothing out the picture of the lady and the edge detection, those are all on the GitHub page. You guys have been to the GitHub page before, right? It's under a folder called OpenCV Demos. The link is in the Google Doc that we're for online people. The link's in the Google Doc. Skulltech, it's also in the Google Doc. Just on the GitHub page. You can try running those as well. Those are also really cool, and make sure you can all three of these things work. So face detection, edge detection, and smooth blur. Okay? Make sense? Okay, I'm going to roam around for the next few minutes for any people with last-minute questions, but otherwise there's office hours today and Tuesday of next week. Okay?
Hey guys, I think it's going to take 5 minutes to set everything up. Do you want to? Yeah, I think it's like 5 minutes.
So before we wrap up, I just want to say that now that we have done our first 3 or I guess 4 classes now, we started with the basic concepts, went with camera fundamentals, then we did light fields, now we're doing computer vision. So in 4 weeks, I think you have a long way, and hopefully you already have something you can show to your mother, when you go home for your weekend. As we go on, we're going to do some really interesting things. We're going to build apps that use more computer vision. We're going to do apps that look at health data, like look under your skin, for example, by adding hardware attachments and doing some electronics on top of it. Then we will get into web crawling and looking at data online. Then we can do web crawling and acquire data from online sources and bring them in. We will play with some user interaction on that. And then, of course, it's not just about cameras. We're going to bring in time-of-flight cameras. We're going to look at thermal IR cameras. We're going to look at things like leap motion, and of course, we already looked at Kinect. So there's a lot coming as we go forward. And some of them are assignments, and some of them are straightforward projects. What I would like you to do is... Skoltek, can you hear me?
Yes.
Okay, so what I want you to do right now, over the next few days, is start writing out some ideas for your projects. And I don't want 1 idea or 2 ideas or 3 ideas. I want to have 10 ideas from each of you. Okay? And then we will take them together and we'll start to cull them down. And then we'll start forming teams, maybe individual 2, maximum 3, given your skills and the scope of the project. And then you can start some progress towards your project. And then starting next week, every week, we're going to come back and look at what kind of progress you're making. In the beginning, it's just brainstorming, and we'll get people like Rick Fulop and some entrepreneurs to help you think about what makes sense. And then we'll bring a panel of entrepreneurs who have built apps and have some reaction to them, also help think through that. Okay? So, but remember, it's not just about Android apps. The next phone might have a time-of-flight camera. In fact, I can almost confirm it. I cannot tell you who, will have a time-of-flight camera in it. There are things like Pelican that's releasing high-foot cameras on their phones. So don't limit yourself to the phone that's available today on Android phones. In the next 6 months or a year, you're going to see all these technologies in your hands. Yes.
But if we design for that, how do we test?
Right. So the trick we used for light field cameras was we said, okay, you may not have light field on your phone, but right now we're just going to move it mechanically and collect a sequence of pictures. And so your program basically deals with light fields already. It's just that you have to do this clunky mechanical process. And for time of flight, we might give you some other data, or you can attach a time of flight camera through an IP socket so that you can take real-time data on that. So there'll be new types of data you can collect. And same thing with multispectral. I can guarantee you it will be in your phone in the next 2 years. So this is a very exciting time of what you can do. I mean, everybody's just pushing the technology. You probably heard the announcement from Samsung of curved phones. What comes to you as a computational camera person? Somebody says you have a curved screen display. What's the first thing that comes to your mind? 3D. What else? Sorry? You can put it on clothes. Very good. You can use it as a calibration pattern. Think those of who think mathematically, planes are degenerate for many operations, but now if it's more interesting with it. You can use for scanning. So I want you to continue to think, and there's an amazing war that's going on out there between phone makers and device makers and gadget makers. And let them fight, because it's going to help us get all kinds of cool technology in our hands. So we don't want to simply react to what they're doing. We want to be one step ahead in what we're developing in this class. Because we want you to be developing the first apps the day that technology is available in people. Okay? So again, don't limit yourself to what you're seeing in the camera and photo app store right now at all. Think of all the things that Dan had, the whole grid of 12 computer vision things, time of flight and all that, and come with your 10 best ideas. They all may be, all over the place, and will help you cull through them. Is that a good plan? Please join us for office hours. We have an amazing team. This is a huge team that's helping you participate in this class. Nikhil is an expert. Daniel, Dan, Rohan, John, me, Rick Phillip. We have an amazing team here who's helping locally. Also at Skoltech, we have Victor, who's an expert in computer vision and mobile phone programming. We have a great team out there as well. And of course, we have a lot of resources online. We have 100 people online who can help you collect data and be your beta testers. Remember when Noah was saying he has to go to the very street and be worried about getting arrested? You have 500 people who can try these things out for you. They can send it back to you. All right. So just to summarize, at 5:30 is the open office hours. Next Tuesday, again at 5 o'clock, we have office hours. In the meantime, think about your project ideas. Any questions? It's usually RGBD. So we'll have a bunch of time-of-flight cameras for you. Right. It'll be 2D sensor. 2D sensor with time-of-flight. Yes. Or it will be structured light like Kinect. But nevertheless, finally, for every pixel you have depth. This is an exciting time to be in this business. The fact that we can do research on it with the latest SDKs is quite exciting. All right? See you next week. So we just want to spend a couple of minutes with Skoltech to wrap up, see if you have any questions or any challenges you're facing right now.
Sorry, people are recording from the bus, that's why.
You're on mute.
Okay.
Yeah, I can hear.
Yeah. Thanks a lot. Just for the bus, the late bus, so that's why I started to empty.
And Victor, I will connect you with Dan, who just spoke, and we would like to set up the assignment in time.
I can't hear what you're saying, sorry.
I'll send you an email. I'll send you an email.
Okay, thanks.
So, yeah, I saw Jay, and so, so you guys all